Hello students, so in our series of crash course, today we will study P block elements third part, and this will be day 23 of our 40 days JEE crash course. This is disclaimer. Students, in today's lecture, we will learn about the group 14 elements, which means elements of the carbon family. After that, we will cover some important properties of the same. Then we will finally learn about some important compounds. So, first we are going to look at the introduction of group 14 elements. So, the element of carbon family are carbon, silicon, germanium, tin and lead. All of them belong to the group 14. Carbon is a non-metal. Carbon is the base of organic chemistry, as you all know, whereas silicon and germanium are metalloid. Then tin and lead are metals. Now coming on to group 14 elements general electronic configuration. So it is Ns2Np2, which means that they possess 4 valence electrons, 2 in the outermost s orbital and 2 in the outermost p orbital. This configuration gives them a valency of 4. In the ground state, the valence shell electronic configuration of group 14 element is Ns2Np2. Here n represents the principal quantum number, which also indicates the period number of the element. As we move down the group, the value of n increases. So 2 for second period, 3 for third period, and so on. The s orbital can hold 2 electrons, while the 3 p orbitals can hold up to 6. In this case, only 2 are present. When one electron from the ns2 orbital gets excited to the p orbital, the configuration changes from ns1 NP3. Okay, it changes to NS1 NP3, and now the atom has 4 unpaired electrons available. This allows group 14 element to share all 4 electrons and form 4 covalent bond, expanding their valency to a tetravalency. Okay, so if I consider it for carbon, it will be 2s2 2p2. Then if I consider it for silicon, then it will be 3s2 3p2. And similarly, if you go on to germanium, then you have tin, and then we have lead. Okay, next let us study about the important trends and anomalous behavior of the carbon. So, first, let us look at the meaning of catenation in one line. Self-linking ability. Okay, so this is your self-linking ability. Through catenation property, carbon can repeatedly link with itself to form a large chain and complex structure. All this is due to its property. Now, carbon has the capability of catenation, tetravalency, and forming long chain structures. Due to these reasons, carbon is so famous and found in almost everything. The tendency for catenation is highest in carbon and decreases gradually down the group. This is because the strength of the element-element bond weakens. So we have seen a similar question regarding this catenation property in the previous class also, and it was regarding this group 14 only. So as we go down the group, leading to longer bond lengths and reducing stability of chains. As a result, the ability to form extended covalent networks diminishes. Therefore, carbon with its strong CC bonds shows maximum catenation tendency, while this property decreases significantly in silicon, germanium, tin, and then lead. Now, we can see its order here. It is highest in carbon, then very low in silicon, then in germanium, which is almost equals to 10, and then it becomes very low in the lead. So carbon, silicon, germanium, tin, lead, this is the decreasing order of catenating property, and also the decreasing order of bond length between their similar type of atom. Okay, if you consider carbon-carbon bond, it is the most strongest one. Then comes your silicon, then your germanium, silicon, and tin and lead. Next property is allotropy. So allotropy means that a single element can exist in different form, which have different physical properties. So all elements of group 14 except your lead, all of them can exhibit allotropy. Now talking about the carbon, it is found in many allotropic form, both crystalline and amorphous. For example, diamond, graphite and fullerene are crystalline forms. Similarly, coal, charcoal, lamp black are all amorphous form. Now we will discuss these crystalline forms one by one, such as diamond, graphite, and fullerene. So, talking about the carbon's allotrope, first one is diamond. Okay, let us look at the structure of diamond. Each dot here represents a carbon atom and the bond between them are covalent. If we count any carbon atom, we will see that it is bonded to 4 other carbon atoms. This bonding pattern corresponds to sp3 hybridization, giving a tetrahedral arrangement around each atom. Because of this, strong 3-dimensional covalent network is the hardest natural, or diamond is the hardest natural form of the carbon. So you can see here that we have one atom here, and each atom is attached to 4 other atoms, and it is done in tetrahedral fashion. Now you can see that this is true for all of them, and hence it is creating a 3-dimensional structure which is very rigid in nature. Next, then diamond is the purest and hardest form of carbon, we know that, and in diamond each carbon atom is bonded to 4 other carbon atoms. It is tetrahedrali surrounded by 4 other carbon atoms. Now you would know what is the bond angle also. It will be 109. Next, this would be a 3D polymer. Its density is very high, along with very high refractive index. Okay, now it does not conduct electricity because it has no free electrons present in it. This means all the 4 electrons of the carbon are used in making bonds, and therefore it is showing a tetravalency here. If there are no mobile electrons or no free electrons, then what will it directly say? Then it would directly say that it cannot conduct electricity, meaning that it is an insulator. Now, diamond is used in cutting, grinding, drilling instruments, and also in making jewelry. Due to being the hardest form, it is used for drilling as well. Okay, so these are some common points regarding your diamond and also its uses. Next, the second allotrope of carbon is graphite. So this is the structure of graphite. It has a 2-dimensional layered structure. Okay, in contrast to the diamond, which was a 3-dimensional structure, here we are seeing layers which are attached to each other, and each layer is 2-dimensional in nature. Got it? Now each carbon atom is covalently bonded to 3 other carbon atoms through sp2 hybridization with a bond length of about 0.14 nanometer. The 4th valence electron of each atom is delocalized across the layer, which makes it a very good conductor of electricity, and this is the only non-metallic form of your carbon which is having a property of conduction. Got it? The layers are stacked one above the other and are held together by weak van der Waals forces, which is particularly due to its higher molecular mass. Then the interlayer distance is about 0.34 nanometer. But because of this weak forces between the layers, the layer can easily slide over upon each other. So they can just slide over each other, and this is the reason your graphite is also used as a lubricating agent. Okay, and it has distinct physical property as compared to the diamond. Then next, if I just put it in points, so graphite has 2-dimensional layered structure, as we can see in the diagram. So this would be the first layer, then here is the second layer, and here is the third layer, and between each of them we have van der Waals force. Got it? Next, in graphite you would see that each carbon is sp2 hybridized because each carbon is attached to only 3 other carbons. So you can look at any of the ball that is present here, and you would see that each ball is attached to only 3 other carbon, whereas in the case of diamond each carbon was attached to 4 carbons. As a result of this, it would have a sp2 hybridization. Now this means it makes 3 strong covalent bond with 3 other carbon atom in same flat layer, forming a hexagonal pattern, basically of 6 member. The 4th electron of each carbon atom does not take part in bonding, and therefore it is free to move. So these free electrons from each carbon is the one which is responsible for conducting electricity in the graphite. Next, the planar hexagonal rings fuse together. Together they form sheets of 1 atom thickness. Okay, so it's very clear since the sheet is containing of one atom here, therefore its thickness will be almost equals to the one atom. For each layer, the thickness is equals to the one atom's diameter. Next, last point. So these sheets are held together by weak van der Waals forces, and these layers can slip over each other. And that is the reason we use graphite as a lubricant. Now, moving on to the next, which is the third. What is the third allotrope of carbon? So the third allotrope of carbon is fullerene. You must have studied about this fullerene in the in your 10th class as well. Okay. So let us discuss about this fluorine. Now, fluorine can be of different types. Mostly we study about this C60 or the Buckminster fullerene. Okay, so fullerene is a group of carbon atoms. Now, this is a specific type of fullerene which is known as C60. We have C32, we have C40 also, and all of them come under this same fullerene. But for you, it is important to learn about this C60. Now, what are the specific nature about the structure? So, this is the structure of your C60 fullerene, and it is also known as Buckminster fullerene. So, it is a type of fullerene with the formula of 60 carbons joined together, and it has a spherical shape resembling a soccer ball. In the structure of C60, each carbon atom is bonded to other by covalent bonds, forming both pentagons and hexagons. You can clearly see that we have hexagon also here. See, this is the hexagon and this one is the pentagon. So, both type of circular shapes are possible here. Next, pentagons are always connected to hexagons, while hexagons are connected to both pentagons and other hexagons. You can see here that this is your pentagon. On each side, you have a hexagon present. 1, 2, 3, 4, and 5. So, on the 5 sides of your pentagon, you have 5 hexagons. But if I talk about hexagon, it has both pentagon and hexagon. See, on the right side of this hexagon, we have one hexagon here, but on the top side, we have pentagon. Got it? So, this is very, very important to see. Next, what is the count here? Just try to remember there is a proper count for this number of hexagonal and pentagonal structures. So, just think about it. So, we will talk about this in the next point. Before that, so fullerene are the only pure form of carbon because they have smooth structures without having dangling bonds. These are cages like molecules. So, this is forming a cage. Inside it, there is a cavity present. Next, C60 is made up of 12 50-membered rings and 20 6-member rings. Okay. So, there are 12 pentagons present here and 20 hexagons present in the Buckminster fullerene. Okay, not 55. Means 12 5-membered, not 50-membered. Next, the 5-membered rings are connected to 6-membered ring always, as we have seen earlier. And your 6-membered ring can be connected to both hexagon as well as pentagon. Got it? Lastly, if I look upon the use of fullerene, so it is used as a microscopic wall bearing. You must have seen a bearing in your cycle, but it is of larger size. But these fullerene are of very small size and they are used in small mechanical objects as a ball bearing. Next, they are also used in lightweight batteries, new plastics, and synthesis of new drugs. Fullerene are also widely used in the medicinal chemistry. Next, talking about the chemical properties. So, this was about the physical properties. First thing would be oxidation state. Okay. So, the common oxidation state which are exhibited by the group 14 elements are +2 and +4. Carbon also shows oxidation state of -4 when it is attached to 2 oxygen, suppose. In that case, it has an oxidation state of -4, which is CO2. Next, group 14 elements have 4 valence electrons. This means that they can use its 4 valence electron to form covalent bonds. We often see that oxidation states are either +4 or +2. As we know, when we move from top to bottom in a group, the size increases. With increasing size, d and f orbitals are also introduced, and as a result of this introduction, they show poor shielding effect. Due to this poor shielding effect, the ns electron, means the outermost s orbital electrons, are more strongly attracted towards the nucleus and they refuse to take part in the bonding. This phenomena, as we know that from the previous class, is known as inert pair effect. So, down the group, the stability of plus 4 oxidation state decreases and the stability of plus 2 oxidation state increases. This means that if it is plus 4, then it can quickly go to plus 2 by reducing it by 2 units. Okay, by reduction it can go quickly to 2 units. And as we go down the group, the stability of plus 2 increases and the stability of plus 4 decreases. So this is very important. So if I specifically talk about germanium and all, and then they are more capable of showing the plus 2 oxidation state rather than the plus 4. And we will look about it in the compounds of the same. Next chemical property is reactivity towards oxygen. So when group 14 elements are heated in oxygen, they react to form oxides because of their ability to combine with the oxygen atom through covalent bonding. Now, non-metallic oxides are acidic in nature, as we know. So carbon, silicon, germanium oxide, all these are acidic in nature. SnO2 and PbO2. So this will be your oxides of tin and lead. They are amphoteric in nature. Got it? Next, which means they can act both as an acid and base. Now, there are some oxides of carbon which are neutral also. So we'll see them. So those are carbon monoxides. I have told you about this. So carbon monoxide is neutral in nature. It is neither acidic nor basic or amphoteric. So among monooxides, your CO and GEO, that means your carbon monoxide and germanium oxide, is completely, your carbon monoxide is neutral and germanium oxide is completely acidic. Whereas your SNO and PbO, that means your tin oxide and your lead oxide, are amphoteric. Got it? So we have to talk both about your monooxides and dioxide because they are capable of showing plus 2 and plus 4 oxidation state. So if I talk about the plus 4 oxidation state, then we have seen that your carbon dioxide, silicon dioxide and germanium dioxide are acidic, whereas your tin oxide and lead oxide are amphoteric. Your monooxides of tin and lead are also amphoteric in nature, but monooxides of carbon is neutral in nature, whereas the monoxide of germanium is acidic in nature. Moving on to the next, the monomeric form of CO2 is stable because d orbitals are not available here, which is why it can form p-pi bonds. Carbon has a tendency to form multiple bonds such as C double bond with O or C double bond with C. We can see the structure of CO2 as multiple bond is formed here. But if I take the case of SiO2, which is silicon dioxide, then in that case, it exists in a 3D polymeric form and has a very high melting point. Due to its high melting point, it remains solid at room temperature. Okay. Now, due to this availability of your SiO2's d orbital, it is also capable of showing hydrolysis reaction, which is not possible for your carbon dioxide because it lacks your d orbital. Next, continuing with the chemical properties, is reactivity towards the water. Okay. So what can we say about the reactivity towards the water? So most of them are non-reactive towards water, but your tin can react with steam, means it can react with water at high temperature to form dioxides and dihydrogen. So if H2O is in the form of steam and it undergoes reaction with the tin, then it can give tin oxide and hydrogen gas. So reaction equation would be Sn plus 2H2O in the presence of heat gives us SnO2 plus 2H2. Next, if I talk about lead, then lead is somewhat reacting with water, but after a time it forms a protective oxide film. Okay, so if you just introduce your lead into the environment, it will react with the environmental oxygen and form a oxide of your form of film of the lead oxide, and this will prevent the lead from further reacting with water. Moving on further with this chemical properties. So next is the reactivity towards halides for group 14. Your group 14 elements form halides of the general formula mx2 and mx4. Again that same thing, due to the inert pair effect, it can also show plus 2 oxidation state. Here M is representing your element and X is any halogen that is possible. So in the plus 4 oxidation state, they form tetrahalides mx4 such as CCl4, SiCl4, GeCl4 and SnCl4, which are covalent in nature and generally volatile also. Whereas in the +2 oxidation state, the heavier members like tin and lead forms stable dihalides, such as SnCl2, PbCl2, and this is completely due to the inert pair effect. You know it very well that the inert pair effect is more significant and only possible in the heavier elements of the group 14 element because they include d and f orbital electrons. Got it? Now, this is the reason the ns electrons becomes inert in response to the reaction and they cannot participate in the bonding with your chlorine and hence they are forming SnCl2 and PbCl2 as we move down the group. Then in the case of germanium, your GeX4 is more stable than GeX2. So here the +2 oxidation state is much more stable. But if I talk about the PbX2, means the +2 oxidation state, then it is more stable than PbX4. Then you can say the same about SnCl2 also. It is more stable than SnCl4 where the oxidation state is +4. As we go down, the stability of the +2 oxidation state is increasing and the stability of the +4 oxidation state is decreasing. SnCl4, if I talk about the physical state, it is liquid at room temperature because it has covalent character. The stronger the attraction, the more it will be in solid form. If the attraction is weaker, it will be in liquid form. Therefore, SnCl4 is in liquid form and SnCl2 is in solid form. Got it? Except for CCl4, that is carbon tetrachloride, all other tetrachlorides are easily hydrolyzed because all of them have empty d orbital. Why it is so? Because carbon lies in the second period and for the second period the maximum principal quantum number possible is 2. Therefore, they can only have 2s and 2p and not your d orbital which is possible in 3/3 shell. Okay. Therefore, carbon cannot expand its covalency because during a hydrolysis reaction what happens, the OH minus part comes and attack into the empty orbital of the given compound to remove its ionizable ions, like in the case of your SiCl4. Okay, so it can remove the chlorine atoms and form and replace it with the OH of the water. So this is your simple hydrolysis and it is possible because your silicon has vacant d orbital. As I told you, so other halides are easily hydrolyzed except for CCl4 because they have d orbitals present. Now we will take the example of silicon. So silicon has a vacant d orbital due to which it can expand its covalency and form higher halides such as SiF6 2-, but it cannot form SiCl6 2-. Why is it so? Because chlorine has a very large size and your silicon is that much not large to accommodate this 6 chlorine atoms around it. So if we try to place these 6 chloride ions around the silicon, they do not fit and therefore 6 large chloride ions cannot be accommodated around the Si4 plus due to its smaller size limitation. You know it very well that as we increase the charge on a given element, its size keep on decreasing because of what? Because of increased effective nuclear charge on the outermost electron, because the count of proton is remaining same but electron is decreasing. Now this decreased size of silicon is trying to accommodate 6 chlorine around it. But what will happen? As a result of repulsion between the chlorine, take an example, if you are having a bigger atom and if you try to put the atoms around it, then it is possible to accommodate much more number of atoms around it. But if your size is smaller and if you try to put a linkage around this with a smaller atom, with a bigger atom, then that will create repulsion. Okay. So you can think it in a simple way. If you draw a circle in a playground and you try to stand around it with suppose 5 people. Got it? Now you increase the size of the circle. Then you would see that more people can stand on its circumference. Similar to that, here also, greater is the size, greater number of your anionic part can be accommodated on the circumference of your given atom. Got it? Moving on to the next one, which is oxides of carbon. So this is something which is very important. So carbon has 2 important oxides. First one is carbon monoxide, which is CO, and carbon dioxide, which is CO2. So let us first understand about this carbon monoxide. How we can prepare carbon monoxide? This very simple reaction we have. So this is basically used in your industries as well, where you heat your carbon with your H2O around 473 to 273 Kelvin, which gives us carbon monoxide and hydrogen gas. And this is collectively known as, this combination of carbon monoxide and H2 is collectively known as water gas. Second one, if we heat two molecules of carbon, okay, with O2 plus 4N2, sorry, two atoms of carbon with O2 and 4N2, then at 1273 Kelvin, it will give you 4 molecules of nitrogen and 2 molecules of carbon dioxide. And this combination is known as producer gas. In both of these cases, you can clearly see that carbon monoxide is formed, but along with different gases. If it is formed along with hydrogen, we call it as water gas. If it is formed along with your nitrogen, we call it as producer gas. Coming on to the part of water gas and producer gas, so they are very important industrial fuels. Got it? Then what is our next oxide? It is carbon dioxide. Carbon dioxide can be prepared when carbon and carbon containing fuels undergo complete combustion in excess air. Carbon dioxide can be obtained as a solid in the form of dry ice by allowing the liquefied CO2 to expand rapidly. Now, solid carbon dioxide is also called dry ice, and it is used as a refrigerant for ice creams and frozen food, which is kept at a very low degree. So, we can store it with them with the help of dry ice. Now, why we use dry ice rather than your simple ice? Because dry ice does not melt quickly, whereas your normal ice, of which is made up of water, it is melting quickly as compared to your dry ice. There is one more application of this dry ice. So in older movies and all, where the possibility of using CGI or any graphic was not possible, so therefore creating an illusion of your ice, uh, producers used to use this dry ice for that same purpose. Okay, so they prepare a set where they throw your CO2 or your dried CO2 around the set, and with the help of that, they shoot their scene of ice. Got it? So this is a very popular thing that is being used in the earlier times also. Next, next we'll try to understand about silicon. So silicon is something which is kind of complicated because it has various structures possible. So for carbon, we have a dedicated chemistry, which is organic chemistry. But for silicon, we have to learn about all its possible compound in this p block elements. So first, we'll try to learn about the chloride, which is chloride of silicon, which is silicon tetrachloride, SiCl4. So of course, it will be tetrahedral in nature, and it is a covalent bond. It forms covalent bond. Then, as I said earlier, it can be hydrolyzed easily with water because it has d orbital present. It fumes in moisture and releases hydrogen chloride. So we can see the reaction. SiCl4 reacts with 4 molecules of H2O moisture to form SiOH whole 4 plus 4HCl. In this reaction, hydrogen chloride is liberated. You can see here HCl. Next, the hydrolysis of SiCl4 occurs because the empty 3d orbitals present in the silicon atom of the SiCl4 coordinate with the OH. Okay, we can understand it this way also. So this is SiCl4. We need to hydrolyze it. It means it will react with water. Here 2H plus is released and 2H are coordinated in this manner. The coordination of 2H occurs with the empty 3d orbital of the silicon atom in the silicon tetrachloride molecule. Next, from here 2Cl minus is released and 2OH minus are again attached to the silicon. Now water reacts again, then again OH and OH coordinate, and again 2Cl negative is released and SiOH whole 4 is formed completely. And how many times? So 2H total of 4H and 2Cl that means total of 4Cl. So 4HCl is released at the same time. Got it? So you can see it clearly in the reaction as well. So first what is happening? First we are adding 2 molecules of water and we are releasing 2H plus along with it. Got it? So you can see first 2H plus is released here. Then next what is happening? Next 2Cl are also released, and this 2H plus and this 2Cl minus is forming the HCl. Again what is happening? 2 molecules of water are coming and 2H plus are releasing from the water, creating a bond between silicon and oxygen. Okay. Then again this OH will remove this Cl, and finally we will get our tetra coordinated silicon with the hydroxide. Got it? Now why is it possible to remove your chlorine with oxygen? So this is very important. You can think about it. So basically, if I consider the bond between silicon and chlorine and silicon and oxygen, then the bond between oxygen and silicon is very, very strong. And the reason is their electronegativity difference. Okay. So elements with a very high electronegativity has a preference over elements with comparatively low electronegativity, and you know that your oxygen has a high electronegativity as compared to chlorine. Therefore, it has a higher tendency to donate electron to the silicon because they can form stronger bonds. Got it? So this same thing is seen in case of phosphorus also. So if you treat your PCl with oxygen, your oxygen donating compounds, then they also remove your Cl of your phosphorus and get attached to the phosphorus directly. You will see those type of reactions in questions also today. Is it clear to you? So this is the reason behind the bond formation and removal of chlorine. Next, we will study about silicons. So what are silicons? So these are synthetic organosilicons, polymers that have repeated units of R2SiO. Now R can be alkyl groups here. And from where do we prepare it? From the alkyl halide. So this is the reaction. So we react here 2CH3Cl plus silicon in the presence of your copper powder at 573 Kelvin. If we perform this reaction, we get R2SiCl2, which means CH3 whole twice SiCl2. Then perform the same process. Here we introduce H2 and HCl will be released and 2OH will be attached, forming CH3 whole twice SiOH whole twice. This reaction occurs via OH coordination. Keep that in mind. Now, what is the repeating unit here? R2SiO. Here R is the methyl group, meaning CH3. So when CH3 whole twice, SiOH whole twice, molecules combine with water, water is released from these units, OH from one and H from another. The unit links through oxygen. So 2CH3 on Si and 1 O here, then 2CH3 on Si. This unit is repeating again and again. Here it will attach to O, and it will continue like this, and this will form the silicon. Got it? So first thing, what is it happening? You are taking the alkyl chloride and you are reacting with silicon. Okay? Then silicon is getting removed, attached to 2 chlorine atoms and 2 methyl groups, since we are taking 2 molecules here. Next, what are we doing? As I told you earlier, that chlorine has a tendency to be removed with the help of oxygen. So if we introduce water here, what will happen? The chlorine that are present here has a ionizable nature. This carbon will not be removed. Okay, your chlorine will be removed. So chlorine will be removed and oxygen will get attached to the silicon. So this is the thing that you will get. Next, what will happen? Such members of which are having OH, they will attach to each other and form a cross linking. And this, after polymerization, what you are getting is known as silicon. Got it? So this is the way you make a silicon. Now, highly cross-linked silicon polymers are obtained when RSiCl3 is hydrolyzed. They are used for sealants, greases, electrical insulators, and waterproofing of fabrics. Due to being biocompatible, they are also used in surgical and cosmetic implants. Next, we'll study about a very important group of silicon compounds which are known as silicates. So, a large number of silicate minerals are found in nature. They are of many types, for example, feldspar, zeolite, mica, and apsistones. The basic structure unit of your silicate is SiO4 4-. Now, this will be repeated multiple times to form the larger silicates. What will be the structure of this SiO4 4-? Very simple. There is a silicon in the middle and all 4 oxygens are attached tetrahedrally. Next, the negative charge on silicate structure is neutralized by the positively charged metal ions. When each corner of your SiO4 4- tetrahedral unit is linked with another tetrahedron, the unit linked together is in all direction. This continuous sharing of electron atoms create a strong 3-dimensional network structure. Now, this structure can be of various types. We will look upon this. Next, what will be the possible structure? So first, you should remember that what are the things you need to remember about silicate structure. So generally, the structure of silicates are quite complex, but they mainly differ in few aspects. So there are 2 to 3 points based on which they differ, and they are mainly different on these points. First, how many oxygen atoms are shared? So this question will be asked in your exams. So how many oxygen atoms are shared in your SiO4 4 minus tetrahedra, which is the basic structural units of silicates. I will give you a trick to remember it, that how many oxygen members are shared. Then next, second, the geometrical arrangement of the tetrahedra, means how it is geometrically arranged. It is linear or three-dimensional or two-dimensional. Then next is the number, type and arrangement of metallic cations. You also have the metallic cation part to neutralize this SiO4 4 minus, so that we will also study. So starting with the first type of the silicate. Remember, these are very important. The first one is known as orthosilicate. You remember this in the order. Okay. So these are the simple silicates where the joint is not possible. Means the units are discrete. There will be one unit of SiO4 4 minus, then other unit, then other unit, then other unit. Means they are not linked together. And therefore, they are also called as simple silicates. Got it? So if there are not linkage between two of the SiO4 4 minus, therefore the common oxygen between both of them are 0. Got it? Next is the pyrosilicate. So in pyrosilicate, there is a linkage between two tetrahedral units. Okay, means they are not present in discrete form, means two are attached together, and such the dimer is overall in the pyrosilicate. So a pair of two is present everywhere. And in this case, since two are attached to each other, therefore one oxygen atom is being shared in this case. And its general formula is SiO2 O76 minus. It's very obvious. When you are attaching these two, then we are getting it as 76 minus, because two oxygens are completing their valency, and hence we don't need a negative sign. Got it? So here, what are the number of oxygen atoms which are shared? It is 1, because two units are joined together and between one oxygen is present. And its common formula is SiO2 76 minus. What is the next one? Next one is known as the cyclic silicate. Remember, the oxygen count, means the oxygen atoms that are shared, are similar in your cyclic and your linear chain. Here, the tetrahedral units are being attached in a linear fashion, means you will see a single line, and then they can be of nth order. Okay, here we are not defining any number here. In the first case, they were presented isolated tetrahedral units. In the second case, pyrosilicate, they are present as dimer. In the third case, we have a linear chain. Now it will depend upon the number of units, that how much charge will be on the given compound. Okay, so for nth number of units joined together, the charge will be 2n minus. Their general formula is SiO3 n 2n minus. Got it? Or you can also write it as SiO3 2 minus of n unit. So both are good to write. How we are saying it? Suppose if I use this formula, that means that nth unit are there, and this charge will be repeated nth time. So that will create a 2n minus charge, or you can write it in this way also, directly by writing the charge outside rather than keeping it in inside the bracket. So both are same in a way. Moving on to the next type of silicate. As I said earlier, in this case also there are two oxygen atoms which are shared. Okay, so one silicate is sharing two atoms. Why? Because here is a linear chain. Okay, on both sides we have a silicate present. So each silicate will share 1 oxygen on each side, creating 2 oxygen share. So what are we counting here? We are counting the number of oxygen atoms which is shared by one silicate unit. Got it? So in both your chain and your cyclic one, you will clearly see that they are forming a chain-like structure, and therefore you will see that 2 atoms are shared here. But here the common formula is different. Okay, what is the common formula? It is it is similar. It is not different. It is same as was in the case of your uh, linear one. So the common formula is SiO3 and 2n minus. So you can also write it as SiO2 minus 3 with n times. Got it? So this is your chain silicate. Next is your sheet silicate. Here 3 atoms are shared together. And the common formula is Si2O5 2 minus with n number of units. Or you can also write it as Si2O5 2n minus with n in the subscript. Okay, is it clear to you? Any doubt till this part? So we started with the orthosilicate, where the number of oxygen atoms which were shared per tetrahedron was 0. In case of linear, it was 2, and cyclic also it was 2. Got it? Whereas in case of pyro, it was 1, and in case of sheet silicate, it is 3. Okay. Then we also looked upon the common formula for your normal, which is ortho 1 unit 1. Okay. In that case, the formula was SiO4 4 minus. In your chain and linear, it is SiO3 2 minus n or SiO3 2n minus n. Then in sheet silicate, it can be Si2O5 2n minus n or Si2O5 2 minus n. Moving on to the next, which is your last one. This is a 3-dimensional silicate. Okay, if I ask you what can we call this sheet silicate? It is is it 3-dimensional or 2-dimensional? It's very easy, right? So we are seeing a sheet here. So sheet is already a 2-dimensional space. Got it? Therefore, your sheet silicate will show a 2-dimensional layer. Now coming on to the third one, which is also known as tectosilicate. So this is having a 3-dimensional silicate, and here all 4 oxygen atoms are shared. Means in this case, your silicate atom, okay, there is a silicon in the middle and all oxygens are present in the tetrahedral form. Now on all oxygens, we have another silicate atom attached to it. This will create a 3-dimensional structure, and therefore the number of oxygen atoms which are shared is 4 per unit tetrahedra. Got it? And what will be the general formula? So I'm leaving this to you. Just think about it. It's very simple to get it. If you know the logic from this part, you can easily know the general formula. Next and the last point. So the 2 important man-made silicates are glass and cement. Do you know how important glass and cement are? So in today's life, glass and cement are very, very important. You can see that cement and glass are being used everywhere. So these are a kind of silicate only. There are so many large buildings where glass and cement are being used, and I hope you have understand the silicate part here. Is it clear to you? So you must remember the names, the number of oxygen atoms which are shared, and the common formula and their structure as well. Got it? So these are some important points you should remember, and you must have seen questions from the same also. Now moving on to the geolites. So this is the last theory part. Then after we will do questions on it. So geolites are also known as shape selective catalyst. So they are used as a catalyst because they have a very definite cavity present. Okay. And they allow reaction to occur on their surface. Okay. They allow reaction to occur on their surface because they provide them a proper cavity to fit in and continue the reaction. So if aluminium atoms are replaced with some silicon atoms in the 3D network of your silicon dioxide, then the overall structure obtained is called aluminosilicate. This is basically a silicate, meaning a 3D network of silicon dioxide, and if we replace silicon with aluminum, we call it aluminosilicate. Through this process, a negative charge appears on the structure, and to balance this negative charge, we have cations like Na+, K+, or Ca2+, which are present. Examples of this include feldspar and geolites. The most famous example among geolites is ZSM5. Now, geolites are used in catalyst in petrochemical industries for cracking of hydrocarbon, so that hydrocarbon can be broken into smaller parts and petroleum products can be obtained. Next, GSM5, which is a type of geolite, is used to directly convert alcohol into gasoline. Hydrated geolites are also used as an ion exchanger in the softening of hard water. So this was all about your group 14 element and its important compound. Now we will do some questions regarding the group 15. So we are trying to cover the whole of your main group element both through questions and through the theory as well. Okay, because here the questions are asked in a theoretical manner. You don't need to practice it, or there is no need to apply mind on it. You have to simply learn it up and apply the same to solve the questions. Okay, if you take the example of silicate, suppose you are being asked that what is the number of oxygens that are shared in case of your orthosilicate per tetrahedra unit. So you don't need to solve it further. You will simply write that the answer is 0. Okay. So I would suggest you to see both the question and the theory part. Now we will do the questions on your mostly your group 15 elements. Okay. There can be questions from group 14 and 13 as well. So this is all the theory part. Just wait for a while. I will just open the question part. So here is the first question. As I said earlier, so questions will be mostly from your 15th group. Okay. Now, among the given members, means we have O2, we have CO2, SO2, H2O, H2SO4, P4O10. You have to decide that which one is responsible for converting PCl5 to POCl3. You have to count the number and simply tell me the correct option according to that. Now, what is the hint for this question? Remember, the compounds which are formed due to linkage between two elements of the same period are very stable. Okay, they will never show a tendency to break and oxygenate other compounds. So it is basically oxidation. From PCl5 we are moving on to POCl3. But if it is a compound which contains two elements from different period, there is a greater tendency to coordinate it to the phosphorus and give the reaction. Okay, as I said it earlier also, so oxygen has a greater tendency to form bonds with phosphorus and your silicon. Now you have to decide that out of this given options, which compounds are formed from the elements that are belonging to two different periods. So first option, if you look, it is oxygen. Now it is very obvious that oxygen is very much stable and it will obviously not react with PCl5 directly without any external agency. And same can be said about CO2, because in CO2 the carbon and oxygen are forming in the same period, and you also know it very well that carbon double bond oxygen are very much stable, and this is the same bond which is seen in case of CO2. But if I talk about SO2, then here the bond is between sulfur and sulfur and oxygen belongs to two different periods. Okay, so oxygen belongs to the second period, whereas your sulfur belongs to the third period. Therefore, it has a greater chance to oxidize other species. So in this case, it would be PCl5. Similarly, your H2O, as you know, that H2O is possibly capable of showing hydrolysis reaction with PCl5. Okay, so it can remove the chlorines. Next is your H2SO4. Here also we have bond formation between the two elements which are a part of different periods. Got it? And we also know that sulfuric acid is a very strong oxidizing agent. Next is your P4O10. Here also, if you consider your PCl5 and P4O10, then P4O10 is something which is capable of oxidizing the PCl5. Now, according to that, what will be the correct answer? Obviously, your O2 and CO2 are not in this counting. Therefore, we are left with 4 other options. Okay. Therefore, the correct option would be option number D. That means 4 compounds are possible that can convert your PCl5 to POCl3. So, the correct answer will be option number D. Now, let us look at the this solution. So, PCl5 forms POCl3 with the following reagent, and now these are the possible reactions. So that is the logic I have given in the previous part, and this is the possible reaction. PCl5 reacting with SO2, it gives us POCl3 and converts SO2 to SOCl2. Next, if I talk about the reaction with H2O, so PCl5 reacts with H2O and gives us POCl3 and converts H2O into HCl. So each of them is donating oxygen and getting Cl from the phosphorus. Next, PCl5 reacts with H2SO4 and gives POCl3 and forms SO2Cl2 Cl2 with the along with HCl. And lastly, your PCl5 reacts with P4O10 to form POCl3. So 6 molecules of PCl5 react with 1 molecule of P4O10 to form 10 molecules of POCl3. You can clearly see that each of these can form POCl3, and I have given you the logic as well. Got it? Next question. Moving on to the next question. When concentrated H2SO4 is heated with P2O5, the acid converts into which of the following compounds? So here are the 4 options. First one is SO3 or sulfur trioxide, then SO2 or sulfur dioxide, then sulfur simply, or mixture of sulfur dioxide and sulfur trioxide means SO2 plus SO3. How you will solve it? So just if you know the answer, you can comment it in the comment section, or I will give you some hint regarding it. Anyone who knows the answer? What you have to do is to do a reaction between P2O5 and H2SO4. Okay, so let me give you a hint. If you talk about this P2O5, so it is a dehydrating agent. Okay, means it will remove water from H2SO4. Now, just think about the product that can be formed. I hope it makes sense now. You can now get your answer quickly. What you have to think? You have to think that your P2O5 is a dehydrating agent, means it can remove a water molecule from H2SO4. So what will be the product of if you remove a water molecule from H2SO4? I hope now this is easy for you to solve. Okay, so it's very simple. If I remove a water molecule from H2SO4, then 2 atoms of hydrogen will be removed and 1 atom of oxygen will be removed. So you will be left with SO3. Therefore, the correct answer will be what? The correct answer will be sulfur trioxide, option A. If I talk about the reaction, then the corresponding reaction will be when your concentrated H2SO4 is heated with P2O5, then your acid is converted into sulfur trioxide following the given equation. So 2H2SO4 plus 2P2O5 giving us 2SO3 plus 4HPO3. Next question. Here what you have to say that out of the given options, which one will show a +3 oxidation state for both of the elements in the pair? Okay. Option 1, pyrophosphorus acid and hypophosphoric acid. Number 2, orthophosphorus acid and hypophosphoric acid. Number C, pyrophosphorus acid and pyrophosphoric acids. And last one, orthophosphorus acid and pyrophosphorus acids. Now, to solve these kinds of questions, there are 2 options. Okay. First thing, you draw the structure, if you know the structure for each of them, and then calculate the corresponding oxidation state. Or else, you can remember a simple trick. What is that simple trick? Now to understand this simple trick, you can take analogy from your iron. You know that when your iron is present in +2 oxidation state, you name it as ferrous, right? Ferrous chloride, for example. And when it is present in +3 oxidation state, you call it as ferric, meaning that for higher oxidation state, you use the term ferric, and for lower oxidation state, you use the term ferrous. Now you have to think that what are the possible oxidation states of phosphorus. So there are 4 possible oxidation states of phosphorus, which are +5, then we have +4, then we have +3 and +1. Your +4 and +5 oxidation state are for the equal, means the phosphoric or hypophosphoric or orthophosphoric, whereas your lower oxidation state, which is +3 and +4, are for us1, meaning that it is possible for pyrophosphorus acid or orthophosphorus acid. Got it? Now this simple trick can easily make you clear, help you to make this question clear about the options. You simply see that out of the given options, which is showing us against it. The first option we have pyrophosphorus and hypophosphoric. Of course, your ick is present here, therefore oxidation state it can possibly have is the +5 and +4. Therefore, this is not the correct option. Option B, again we have one ick present in the second part of the pair. So first one is orthophosphorus, but the second one is hypophosphoric. As soon as you see ick here, therefore the oxidation state possible for ick are +5 and +4. Similarly, for option C, if you see, then the second element of this pair is pyrophosphoric acid, means the oxidation state would be probably +5 and +4. But if you look upon the option D, then the options are containing orthophosphorus and pyrophosphorus, means both are having us as the last one. Therefore, they will of course show the +3 and +1 oxidation state. But still you are in dilemma. But the point is that other 3 options are already eliminated. Therefore, you don't have to think about it further, and you can clearly say that the option D would be a correct one. Okay. So coming on to the correct answer, it is orthophosphorus acid and pyrophosphorus acid. Now, you can also draw the structure or you can calculate the oxidation state. So first of all, talking about the orthophosphorus acid, whose formula is H3PO3. So just put the values here for different oxidation states of oxygen and hydrogen. Therefore, for hydrogen it will be 3. For 3 hydrogens, for oxygen it will be 3 into -2, that means -6. Assume that phosphorus is having an oxidation state of X. If you find its value, it will be +3. Next, talking about pyrophosphorus acid, which is H4P2O5. Here, what we will do, we will again assume that the oxidation state of phosphorus is X, and for hydrogen it will be +1, and for oxygen it will be -2. Therefore, solving it for X, you will get it as +3. So in both of them, we have the +3 oxidation state. Now question comes, how do you remember these formulas? Because you have a lot of oxo acids that are coming from phosphorus. So let me tell you a very simple trick. So there are some changes in it as well, but a very simple trick is there. First of all, you have 2 groups, which are us and ick. Got it? So remember, us, which is your hypophosphorus or orthophosphorus, is always for +3 and +1 oxidation state, whereas +5 and +4 are for ick. Next, under phosphoric acid, we have H3PO4. Okay, whenever you see phosphoric acid, we have H3PO4, and under it we have various compounds which are possible. We'll talk about it. And the other family is phosphorus acid, and here the formula is H3PO3. Okay, so these are the 2 possible ones, H3PO4 for phosphoric and H3PO3 for phosphorus. Now, orthophosphorus and phosphorus are the same name, means they are for the same compound, means they represent this same H3PO3. Similarly, your phosphoric acid or orthophosphoric acid represent the same chemical formula, which is H3PO4. Is it clear? So just note it down as I am telling it. So first I will discuss about this us1. What did I say? So us means your phosphorus or orthophosphorus has a formula of H3PO3. Next, what you do, you remove one oxygen from it. What you will get? You will get H3PO2. And if you remove one oxygen, always remember you have to add a hypo. So its name would be hypophosphorus acid. As simple as that. And in place of removing oxygen, if you add two molecules of your phosphorus acid and remove one water molecule, that means if you add H3PO3 plus H3PO3, what you will get? H6PO6 and remove one water molecule. What you will get? In the last, you will get it as H4, okay, O5P2. Got it? So this is the one that I'm talking about. H4P2O5. After removing one water molecule, you will get this molecule, and this is known as pyro. So two possibilities are there. First is if you remove oxygen, it will give you your hypo, and if you remove water by adding two molecules, first you add two molecules and then you remove water, then you call it as pyro. Now coming on to the ick part, okay, coming on to the ick part, what you can do, its formula is H3PO4. Now here if you remove only one oxygen, what you will get? You will get H3PO3, which is your phosphorus one. Therefore, you can't remove it directly. Okay. So first of all, here you will add two phosphoric acid molecule, add them together, remove the water molecule, and then what you will get? You will get your what? You will get your pyro one, means your pyrophosphoric acid. And further, if you remove the oxygen, then you will get the hypophosphoric acid. So in the first case of phosphorus, if you remove simply your oxygen, then you will get your hypophosphorus. If you add two of them and remove water, you will get pyrophosphorus. Whereas in the case of ick one, if you add two molecules together and remove water, what you will get? You will get it as pyro. And after that, if you will remove oxygen from the same pyrophosphoric acid, then you will get the hypophosphoric acid. So this is the simplest way to remember the structures. Now next thing is drawing the simplest way to remember the formulas. Next thing is to remembering the structure. Remember one thing. First of all, you must have a P double bond O in every oxo acids of phosphorus. Okay. And next thing you should remember is that you should always have hydrogen attached to oxygen until and unless there are oxygen present. So there will be one P double bond O. Other than that oxygen, every other oxygen will be singly attached to the phosphorus, and the other part of the oxygen will be attached to hydrogen. So this is the case where you have one unit. If you add two units and remove water molecule, so in that case two PO bonds are there. Next, the remaining hydrogen bonds, which hydrogen atoms which cannot be attached to the oxygen, they directly go on to the phosphorus. Okay, so this is a trick for you. You can just try to remember the names of these oxo acids in the similar fashion. Moving on to the next question. Here the question is given as white phosphorus on reaction with NaOH with pH 3 gives us one of the gives one of the reactions. Okay, now what is that reaction? You have to decide. First one is dimerization reaction. Second one is disproportionation reaction. Third one is condensation reaction, and fourth one is precipitation reactions. Now this is an important reaction of your phosphorus element. Okay, how you can remember it? Always remember that your given oxidation state of white phosphorus, which is P4. Okay, so P4 is something which is not stable at all. As soon as you react your unstable white phosphorus with NaOH, it will quickly react to undergo disproportionation reaction. Now this is generally seen in those compounds. This disproportionation reaction is seen in those compounds which are unstable or less stable. They quickly take the course of disproportionation. What is the meaning of disproportionation? You know it very well. It goes in a higher oxidation state as well as in the lower oxidation state, means it is oxidizing itself as well as reducing itself. So the correct answer would be disproportionation reaction, which is option number B. And what will be the reaction corresponding the same? So when you treat your white phosphorus with NaOH, it will give pH 3, and this is the reaction P4 plus 3 NaOH plus 3 H2O. giving us 3NaH2PO2 pH3. So here if you look upon pH3, then what is the oxidation state here? Anyone? So what is the oxidation state if you look upon pH3? If you want, you can just comment it here. It's a very simple question. Okay, so that would be -3. Got it? So your P4, which is in zero oxidation state for phosphorus, is going to -3. Now here, what will be the oxidation state? So for sodium, we will take it as +1. For hydrogen, we will take it as +2. So +3 all over, and here it is -4. So to completely balance it, here it will be +1 for phosphorus. That means your zero oxidation state of phosphorus is going to -3 as well as +1 both. Therefore, this is a classical example of disproportionation reaction. Next question. Among the given molecules, which has the smallest bond angle? Again, it is a direct question from a group 15 element. So all these are members of the group 15, NCl3, ASCl3, SbCl3 and PCl3. So here we have nitrogen, arsenic, antimony and phosphorus. How you would handle this question? Always remember a trick. As you move down the group, the bond angle always decreases. Okay. So you will see it in each case. So whenever you move down the group, the bond angle decreases. Now you have to decide that which member of your group 15 element is coming in the heaviest element part. You have nitrogen, arsenic, antimony and phosphorus. So what will be the answer here? Anyone, can you tell me how you will tell the correct answer? You have to just see that which one is the last element of your group 15 element. So let me give you a trick to remember the same. It's very simple. Nu police assigns subordinate Bikram. Okay, so Bikram means your bismuth, N means nitrogen, nu, police means phosphorus, then assigns means your As arsenic, subordinate means your Sb which is antimony, and lastly is your Bikram which is not given here, which is your bismuth. Okay, so what is the correct way to learn it? If you want, nu police assigns subordinate Bikram. Now from that part, it is very clear that the last element possible for your group 15 element, group 15 member group is given here as your subordinate, which is antimony chloride. Therefore, your correct answer would be C. Very good, Varsha. It will be C, SbCl3. So how do you make it possible, or how do you rationalize this? Why is the bond angle decreasing down the group? So first of all, let us see the order. So first we have nitrogen, then we have phosphorus, third we have arsenic, and lastly we have antimony, which is Sb. So nu police assigns subordinate Bikram. Last one is bismuth. It is not given here. So these are all the members of group 15 elements. Then in group 15 element, the valence electron count is 5 and your +3 oxidation state is shown by the molecules. Now remember, your MCl3 means your M is representing the group 15 elements, has M element along with one lone pair. Okay, so it has a lone pair here. This means there are 3 bond pair and 1 lone pair. Next, there is a repulsion between your lone pair and the bond pair, and that decreases your bond angle from the actual one. However, in the case of SbCl3, the bond pairs of electrons are quite far away from the central atom. Why? Because the size of antimony is very large. So the atoms around it are very far away from each other. As I said earlier, if you take a smaller circle and put 2 people across it, suppose I am putting 2 people across it, then they will be closer to each other. Now if I take a bigger circle, then the diameter will be increased. So the 2 people, if I put across each other, then they will be far from each other. Similar to that, if you put chlorine around a bigger antimony, that will result in less repulsion. Therefore, they can be in a smaller angle, okay, as compared to the nitrogen. Thus, we can say that the lone pair causes more distortion in your nitrogen, phosphorus and arsenic as compared to the antimony, and hence antimony is having a less bond repulsion and lowest bond angle. Got it? Is it clear to you? If you want to remember it in a tricky fashion, it's very simple. You will see it always for hydrides and chlorides or of every group, that as you move down the group, then the bond angle decreases. Okay, means the angle between the bond pair and the bond pair decreases down the group. Next question. Which of the following statements is incorrect? So this was asked in AIEEE 2011. First option is the stability of hydrides increases from NH3 to BiH3 in group 15 of the periodic table. So again, we are talking about the group 15 element and we are moving from NH3 to BiH3. BiH is the bismuth is the last member, as we see from the trick as well, which is new inspector, new police assigns subordinate Bikram. So Bikram stands for your bismuth. Next option, nitrogen cannot form d pi p pi bond. Okay, you know it very well. What is d pi p pi? Means a pi bond formed between the d orbital and the p orbital. So that is d pi p pi. Next one, single NN bond is weaker than single PP bond. Okay, and last one, N2O4 has two resonating structures. Now you have to tell that which one is incorrect. Okay, look upon the incorrect option and not the correct one. So don't make a mistake of choosing a right or wrong option after knowing the answer also. So what will be the correct answer here? Just post it here. Now let us start discussing from the first one. If you look upon the first option, it is saying that as you move from NH3 to BiH3, the stability of the hydride is decreasing. Now, this was also seen in the case of previous groups, and this is also true here also. Okay, so as you move down the group, the hydrides of the element become less and less stable. Why is it so? Because hydrogen is something which is present in the top of the periodic table, and it is a lighter element, as well as it has a very low electronegativity. Okay, so two possible cases are there in forming a stable compound. First, either it should be closer to the period in which your element is lying, your central element is lying, or second, it should have a high electronegativity. So here both cases are opposite of that in the case of bismuth. So bismuth is far away from hydrogen, as well as hydrogen has a very low electronegativity. As a result of that, it cannot make the bismuth electrons to get excited in a good fashion. So it cannot form strong bonds. As a result of this, there is no hybridization in the bismuth, and hence the bond angle is closer to 90 degree. Okay, means you know that px py are equals to 90 degree, and since they are not undergoing hybridization, they will remain in that 90 degree angle to form bond as well. Therefore, due to this bad overlap, you will see that they are forming weaker or unstable hydrides. So this statement is absolutely incorrect. So if you move down the group, the stability decreases. Now, moving on to the option B, your nitrogen cannot form d pi p pi bond. It's very obvious, because nitrogen has no d orbital in it, because it is falling in the period number 2, and the maximum principal quantum number value for period number 2 elements is 2. That would include 2s and 2p only. So this is absolutely correct. Option C, nitrogen bond, single bond is weaker than pp single bond. Now don't make a mistake here of choosing the NN bond stronger as compared to pp, because your overall nitrogen molecule is although stable, but its single bond is very unstable. Okay, so the stability that you see in the case of nitrogen molecules comes due to the higher bond order, which is 3 in case of 2 nitrogens attached together. But if you consider a single nitrogen bond, then it is comparatively very weak as compared to the single pp bond. And what is the reason? The reason is the small size of nitrogen. So when you bring the two atoms together, there is a very high repulsion between the electrons of the two nitrogen, and hence their bond is very much weaker. and therefore to make this molecule stable you have to make 3 bonds along with that one. But in case of phosphorus, you know it very well that the P4 is having one single bond along between the phosphorus, and still they are kind of stable, or they are found in the environment. Got it? So this one is absolutely correct. Last one, N2O4. If you draw the resonating structure of your N2O4, you will see that there is a coordinate bond between nitrogen and oxygen. Okay, and there are two coordinate bonds, each with one nitrogen and two double bond oxygen. Now this coordinate bond can be resonated throughout the structure, and hence it can form two resonating structures. So what will be the correct answer? First one. The first statement is absolutely wrong, that your stability increases down the group. Instead, it decreases down the group. So if I write it here, the thermal stability of hydride decreases down the group in the periodic table of group 15 elements as well as group 14 elements. So you can see the order of thermal stability in this image. For group 15 elements, we can see BiH3, SbH3, ASH3, PH3 and NH3. This is their decreasing order. This means NH3 is the most stable and BiH3 is the least stable. And of course, you can see one more important thing that I have written, the bond energy in kilojoule per mole for each of this. But for BiH3, it is not written here also, because it is not possible to calculate it because the compound is not stable at all. So with increasing size, the hydride does not remain as stable. What happens with the increasing size? The bond length between them increases, and so the bond will easily break. We can see the MH bond energy is BiH3 is not given, but for others it is 255, then 297, then 322 and 391. So BiH3, it is for it is not predictable, meaning it is very unstable, so it will break quickly. Therefore, this statement is not correct at all. Moving on to the next one. So on option number B, due to the absence of d orbital, your nitrogen cannot form d pi p pi bond. Okay, it can form p pi d pi bond, means d orbital of the other one and p of itself. But here d is written in the first part, means d pi is written in the first part. It means d orbital is coming from the nitrogen, and that is not possible. So this statement is absolutely correct, that nitrogen cannot form d pi p pi bond. Therefore, this is correct. Moving on to the next option. So next one is, if you look upon the nitrogen bond energy, it is 160 kilojoule per mole, whereas a phosphorus single bond, it is higher, which is 209 kilojoule per mole, and the reason is your smaller size of nitrogen, which creates a very high repulsion. Therefore, this statement is correct. Next one, does N2O4 has two resonating structure? Yes. So these are the two possible resonating structure of N2O4. So this two coordinate bond that you are seeing, it can resonate onto the opposite side and hence create the second resonating structure. Therefore, this is also correct. So this was all for today's class. In few minutes, our maths faculty will join you. Thank you for joining the session.
Hello everyone. So, in today's class, we will discuss differential equation. Okay. So, at first, we will summarize the theory of differential equation and then we practice question on differential equation. Because in last class, we already discussed the theory of differential equation. So, in today's class, we just summarize the differential equation theory. Okay. So, what is differential equation? So, differential equation is also a mathematical equation which relate a function with its derivative. So, equation involving dependent variable, independent variable and derivative of dependent variable with independent variable with respect to independent variable is called a differential equation. And it describes how a quantity change over time or space because a derivative is just a rate of change. So, a differential equation describe how a quantity change over time or space. Okay. So for example, dy by dx is equal to 3x square is a differential equation. And this equation tells how y change with respect to x. And this sequence, so this equation involving derivative of a function and variables. So this is your differential equation. Now, what is order and degree? So order is highest derivative present in the given differential equation. And what is degree? So degree can be defined and cannot be defined. So a degree is defined if your given differential equation is polynomial with respect to derivative free from radicals and fraction. Okay, fractional power. Then the power of highest order derivative present in the differential equation is your degree. Okay, next. So for example, the differential equation d2y by dx2 whole power 2 plus dy by dx whole cube is equal to y. Then what is order and what is degree? So order is the highest derivative present in this equation. So that is d2y by dx2. So order is 2. And if you are talking about degree, then for degree, to define degree, at first check this, is this given differential equation is polynomial with respect to derivative or not. So this is polynomial with respect to derivative d2y by dx2 and dy by dx. So we can define degree. So degree is the power of the highest order derivative present in the differential equation. So that is d2y by dx2 and its highest power is 2. So degree is 2. Now, what is solution of a differential equation? So solution of a differential equation is a function that satisfy the differential equation. When we substitute that function, then that is called solution of a differential equation. There is two type of solution of a differential equation. First is general and second is particular. Okay. So for example, if there is a differential equation like dy by dx is equal to x, then its solution is y is equal to x square by 2 plus c. There are many methods to find solution of a differential equation. So first is, what is general solution? So general solution include arbitrary constant, okay, and it represent a family of curves, okay. And what about particular solution? So if you take this as a solution, and the solution is a general solution for a differential equation, that is y is equal to x square by 2 plus c, there are arbitrary constant c. So if a solution include arbitrary constant, then that solution is called general solution, okay. And if we take a particular value for that arbitrary constant, then we get a particular solution, okay. And this arbitrary constant is obtained by the initial and boundary condition. So if there is a differential equation and we have to solve this, and if there is given any initial and boundary condition for that differential equation, then we can also calculate this value of this arbitrary constant, and when we get this value, then that solution is called particular solution, okay. So boundary condition like y0 is equal to 1, this is the initial condition, okay. So initially there is a condition that the value of y at x equal to 0 is 1. So we can use this value to find a particular solution, as general solution is equal to x square by 2 plus c. So if we take this, substitute x equal to 0, we get y equal to 1. So from here we get c is equal to 1. So particular solution is y is equal to x square by 2 plus c for this particular case. Okay. Now, what is first order and first degree differential equation? So if the differential equation involve only the first derivative and the degree of the derivative is 1, then that type of differential equation is called first order and first degree differential equation. That is, if you are given differential equation, then if the order of that differential equation is 1 and degree is also 1, then that is called first order first degree differential equation. Okay. And what is the general form of first order and first degree differential equation? That is dy by dx is equal to fx y. For example, dy by dx plus y is equal to x. So this is the example of first order and first degree differential equation, because order is also 1 and degree is also 1 for this differential equation. Okay. Now, there are different methods to solve differential equation. First one is variable separable method. Okay. So, if your given differential equation is of the this form, that is dy by dx is equal to gx into hy. Okay. Then we can write this differential equation as 1 by hy dy is equal to gx dx. Okay. So we just write the term involving y with dy on the left hand side and the term involving x with dx on the right hand side, and now we just need to integrate this to find the general solution. So this method is variable separable method. For example, there is a differential equation like dy by dx is equal to xy. So we can write this as 1 by y dy is equal to x dx. So now we just need to integrate this to find the general solution. So just integrate both sides. So integration of 1 by y dy is equal to integration of x dx, that is ln y is equal to integration of x dx is x square by 2 plus c. So this is your general solution for the equation dy by dx is equal to xy, and this method is called variable separable method, and this differential equation is called in the form of variable separable differential equation. Okay. Now, some equations are not separable directly but can be made separable using substitution. Okay. So if there is an example like dy by dx is equal to x plus y by x. So this is not in the form of variable separable form. Like this form is not like dy by dx is equal to gx into hy, but by using substitution we can transform it in the form where we can apply the variable separable method, where we can separate the variable. So just use the substitution y is equal to vx. So we get, and then differentiate this with respect to x. So we get dy by dx is equal to vx plus dy by dx. And now use this dy by dx in the original equation. So we get the differential equation with variable v and x. Okay. And now the transformed differential equation is in the form of variable separable form, where we can separate the variable and where we can easily find out the solution. Okay. Another type of differential equation is homogeneous differential equation. So a first order differential equation is homogeneous if it can be written as a function of y by x. As I already discussed, what is homogeneous function? Okay. So the general form of homogeneous differential equation is dy by dx is equal to fy by x. So the given differential equation is of the homogeneous differential equation type if you can write in this form, that is dy by dx is equal to fy by x. Okay. Then how we can solve the homogeneous differential equation? We just need a simple substitution, that is y is equal to vx. So if we use this substitution y is equal to vx, then we can easily solve the homogeneous differential equation. Like in this example, like there is a dy by dx is equal to x square plus y square by xy. This is a homogeneous type. So here we use the substitution y is equal to vx and then differentiate it with respect to x. We get dy by dx is equal to v plus x dy by dx. So we use v plus x dy by dx in place of dy by dx, and then we can easily solve this homogeneous differential equation by a simple substitution y is equal to vx. Okay. Another form is linear differential equation. So what is the form of first order linear differential equation? That is dy by dx plus pxy is equal to qx. And to solve this, we need to find the integrating factor, and that integrating factor is find out by e the power integration px dx. Okay, so by using this integrating factor, we can easily solve the linear differential equation. Now, another is Bernoulli differential equation. This is a non-linear equation of the form dy by dx plus pxy is equal to qx y the power n. And due to the presence of y the power n, this is a non-linear differential equation. Okay, so we can transform this Bernoulli differential equation into a linear differential equation by a simple substitution, that is v is equal to y the power 1 minus n. And by using this substitution, we can reduce this Bernoulli differential equation into a linear form. Okay, like in this example. Now, another method is inspection method. Okay, an inspection method, with this method involves recognizing the structure of the equation and guessing the solution directly. So in this method, if there is a differential equation, we recognize the equation as a block. If there is some block that can be written as a form of total derivative, where then we can write in the form of total derivative, where we can directly integrate it and find out the solution directly. Okay, okay, so let's solve some question. Question number 7. So the differential equation of the family of parabola with focus at the origin and the x-axis as axis is. Okay, so in this question, there is a parabola whose focus is at the origin. So focus is 0 comma 0, and axis of parabola is x-axis. Okay, now we need to find the differential equation of this parabola. So general solution for this differential equation is family of curve is parabola with focus at the origin and axis as x-axis. And we need to find the differential equation for this family of curve. Okay. So options are option A, y dy by dx whole square plus 4x dy by dx is equal to 4y. Option B, y dy by dx whole square is equal to 2x dy by dx minus y. Option C, y dy by dx whole square plus y is equal to 2xy dy by dx. And option D, y dy by dx whole square plus 2xy dy by dx plus y is equal to 0. Okay, so to solve this question, at first, what is the what is the equation of parabola with focus at the origin and the axis as x-axis? First write the equation and then use the differentiation to find the differential equation. So if there is any equation with some arbitrary constant, so to find the differential equation, we use the differentiation, we differentiate it and eliminate the arbitrary constant. And when we eliminate all the arbitrary constant by using the differentiation, we get our differential equation. Okay, so try. Are you trying? Okay, let's solve. So correct answer is option B, that is y dy by dx whole square is equal to 2x dy by dx minus y. So equation of family of parabola with focus at 0 comma 0 and axis as x-axis is given by the equation y square is equal to 4a x minus a. So this is the equation, okay, and we need to find the differential equation for this equation for this family of curve. Okay, so here a is the parameter, a is the arbitrary constant, there is only one arbitrary constant. So now differentiate this equation 1 with respect to x, we get differentiation of y square with respect to x, that is 2y y1. So y1 is dy by dx, okay, differentiation of y with respect to x one time. So y1 represent this. So 2y y1 is equal to, now right hand side, so 4a differentiation of x with respect to x is 1. So we get 2y y1 is equal to 4a. Okay. So there is only one arbitrary constant. So we only need to differentiate one time. So we get 2y y1 is equal to 4a. So now we need to eliminate this a. And for this, what we do, find out the value of a from this equation. 2y y1 is equal to 4a. So we get a is equal to y y1 by 2. Now substitute this value into the equation 1. So we get y square is equal to 2y y1 x minus y y1 by 2. And just simplify this, take y as common, and so we get y is equal to 2x y1 minus y y1 square. Y is cancel out, so we get only left with y. Now we can rearrange it, so we get y y1 square is equal to 2x y1 minus y, and y1 is dy by dx, so we get y dy by dx whole square is equal to 2x dy by dx minus y, and that is your differential equation. Okay, so to find a differential equation for a curve or for a family of curve, so like there is a family of curve of parabola with focus at 0 0 and axis at x-axis. So at first write the equation for that family of curve, and that equation is y square is equal to 4a x minus a. And now we differentiate this and try to eliminate the arbitrary constant. Okay, and as there is only one arbitrary constant, so we know that order of a differential equation is equal to the independent number of arbitrary constant, and as there is only one, so order of the differential equation is 1. Okay, so we need to differentiate this only one time, so we differentiate this and we get equation involving derivative. Now we eliminate the arbitrary constant a with the help of equation 1 and the equation 2, that is your different, that is 2y y1 is equal to 4a. So by using this both equation, we eliminate the arbitrary constant a, and then we get the differential equation for family of curve. So this is the basic idea how we find the differential equation for a family of curve. Clear? Any doubt? Next question. So the differential equation whose solution is x square plus y square plus 2x plus 2by plus c is equal to 0, where a, b, c are arbitrary constant. So we need to find the differential equation whose general solution is given, because there is arbitrary constant, so this solution is general solution. And if a differential equation is given, you can find its general solution. And if the general solution is given, then we can also find the differential equation, okay, with the help of this general solution. Okay, so as in last question, we know how to calculate a differential equation with its solution, and solution represent the family of curve. So the solution is x square plus y square plus 2x plus 2by plus c is equal to 0, and here there are three arbitrary constant. Okay, so differentiate this this solution and make a different equation and try to eliminate the arbitrary constant a, b and c. Okay, so options are 3y y1 minus 1 plus y1 square y3 is equal to 0, Option B, 3y1 square y2 minus 1 plus y1 square y3 is equal to 0. Option C, 3y1 y2 square plus 1 plus y1 square y3 is equal to 0. And option D, 3y1 y2 square minus 1 plus y1 square y3 is equal to 0. Okay. So by using differentiation, differentiate it, make the equations and try to eliminate the arbitrary constant. Okay. So try. So which option is correct? Anyone? Okay, let's solve. So correct option is option D, that is 3y1 y2 square minus 1 plus y1 square y3 is equal to 0. So given solution of a differential equation is x square plus y square plus 2ax plus 2by plus c is equal to 0. So consider it as equation 1, and now we differentiate this equation 1 3 times. Why? Because there are total 3 arbitrary constant. So the degree of the differential order of the differential equation for this solution is 3. So differentiate this equation 1 3 times, we get 2x plus differentiation of x square is 2x and differentiation of y square is 2y y1 plus 2a plus 2b y1 is equal to 0. Okay. Now we again differentiate this, so we get x plus y y1 plus a plus b y1 is equal to 0. Okay, so this is equation 2. Again differentiate, so we get 1 plus y1 square plus y y2 plus b y2 is equal to 0. Clear? And when we differentiate third time, we get 3y1 y2 plus y y3 plus b y3 is equal to 0. Simple differentiation. We apply the product rule of differentiation. So if we differentiate the equation 1 plus y1 square plus y y2 plus dy2 is equal to 0 with respect to y. So differentiation of 1 is 0 and differentiation of y1 square is 2y1 y2 plus differentiation of y y2 is, so first differentiate y and multiply y2, so we get y1 y2 plus y into differentiation of y2, that is y3, so y y3 plus b into y3. So these are 3 equations that we get when we differentiate our general solution 3 times. Okay, so when we differentiate first time we get equation 2, then we second time we get equation 3, and when we differentiate third time we get equation 4. Okay, now we need to eliminate the arbitrary constant. So in the equation 4 there is only one arbitrary constant, that is b. So to eliminate b we use equation 3 and 4. Okay, so we get how we eliminate, multiply equation 3 with y3 and equation 4 with y2 and then subtract, we get 3y1 y2 square minus y3 minus y1 square y3 is equal to 0. And this is the Differential equation for general solution x square plus y square plus 2x plus 2by plus c is equal to 0. Okay. Question number 9. If x dy is equal to y dx plus y dy, y1 is equal to 1 and yx is greater than 0, then y at minus 3 is equal to. Okay. So there is a differential equation x dy is equal to y dx plus y dy, and also there is an initial condition, that is y1 is equal to 1, that is the value of y at x equal to 1 is 1. Now, and also yx is greater than 0. So what is the value of y at minus 3? Okay. So at first try to find the general solution for the differential equation. Okay. There are many methods to solve. So at first recognize which method is suitable for this differential equation and then find its general solution, and then use the condition y1 is equal to 1 to find the arbitrary constant. Substitute the value x is equal to 1 and y is equal to 1 at the general solution and find out the value of arbitrary constant. And when you get the arbitrary constant, substitute it and get a particular solution, and then calculate y at minus 3. That is, substitute x equal to minus 3 on that solution, you get the value. Options are, option is option A 3, option B 2, option C 1, and option D is 0. So try this question. There are many methods to solve a differential equation, like a variable separable method, linear differential equation method, homogeneous differential equation method, inspection method. So at first recognize which method is applicable for this differential equation. Okay. And then try to solve. As a hint, recall the formula for dx by y. That is total derivative of x by y. Okay, so correct answer is option A 3. So we have x dy is equal to y dx plus y dy, whereas y is greater than 0. This is your differential equation. So we can write this as x dy minus y dx by y square is equal to dy. Okay, we just simplify this and we get this. So if you observe the left hand side of this differential equation, so that is total derivative of x by y. Okay, just take minus common, so you get y dx minus x dy by y square, and we take negative on the right hand side. So that this is the total derivative of x by y. So this is dx by y is equal to minus dy. Okay, and then integrate this. So we get x by y is equal to minus y plus c. Now use the initial condition, that is y1 is equal to 1. So here at x equal to 1, y is equal to 1. So substitute the value at x equal to 1. So 1 by 1 is equal to minus 1 plus c. So we get 1 is equal to minus 1 plus c. So c is equal to 2. Now substitute the value of c. So we get a particular solution, that is x by y plus y is equal to 2. So now we have to find this value at the value of y at minus 3. So substitute x is equal to minus 3. We get minus 3 plus y square is equal to 2y. So simplify this, we get a quadratic equation, that is y square minus 2y minus 3 is equal to 0. So from here, when we factorize it, we use a factorization method to find the value of y. We get y plus 1, y minus 3 is equal to 0. So from here we get two value, y is equal to minus 1 and y is equal to 3. But as it is given that y is greater than 0, so we consider only one value, that is y is equal to 3. So correct answer is option A. Any doubt? Everything clear? Please confirm. Okay, next question. So question number 10, if dy by dx is equal to y plus 3 greater than 0 and y at 0 is 2, then what is the value of y at log 2? Options are 5, 13, minus 2 and 7. Okay, so we are given a differential equation along with an initial condition. So at first we solve the differential equation to find the general solution, and then we use this initial condition to find the value of arbitrary constant, and then we substitute that value of arbitrary constant to get a particular solution of this differential equation. And when we have that particular solution, we find that the value of y at x is equal to log 2. Simple. So at first solve the differential equation. Okay, so differential equation is dy by dx is equal to y plus 3. So easiest method to solve a differential equation is a variable separable method. So can we separate the variable in this differential equation? Okay, so try this. Are you guys trying? Any problem? You can solve this differential equation by variable separable method. So you can try that approach or variable separable method. Just separate the variable, write the term involving y with y and the term involving x with x, and then integrate and find the general solution. And when you have the general solution, then use the initial condition to find the value of arbitrary constant. Okay, and the when just put that arbitrary constant on that general solution, you get a particular solution. And for that particular solution, find the value of y at x is equal to log 2. Clear? Any doubt? So try. Okay, no problem. Let's solve. Correct answer is option D, that is 7. So given differential equation is dy by dx is equal to y plus 3, and the initial condition is y at 0 is 2. So we separate the variable, write the term y with y. So we get dy by y plus 3 is equal to dx. And this is a separable form of variable. Now we just need to integrate this. So integrate both sides, we get integration of dy by y plus 3 is equal to integration of dx, that is log e mod y plus 3 is equal to x plus c. So this is the general solution. Now we use the initial condition, initial value to find the arbitrary constant, and that is y at 0 is 2. So substitute x equal to 0 and y is equal to 2 on the above general solution. We get log e mod 2 plus 3 is equal to 0 plus c. Okay. So c, the value of c is log base e 5. Now we have value of arbitrary constant. So substitute this value into the general solution. We get log base e y plus 3 is equal to x plus log base e 5. Okay. So now we have to find the value of y at log 2. So just substitute the x is equal to log 2. So we get log base e y plus 3 is equal to log base e 2 plus log base e 5. Apply the property of logarithmic. Okay. That is log m plus log n is log mn. So we get log base e 10. So we get from the equation log base e mod y plus 3 log base e 10, we get mod y plus 3 is equal to 10. And from here we get y plus 3 is equal to 10 because y plus is greater than 0. So from here when we solve this, we get y is equal to 7. So the value of y at log 2 is 7. Clear? Any doubt? Simple question. Next question. So the differential equation dy by dx is equal to root under 1 minus y square by y. Determine family of circle with option A, variable radii and a fixed center at 0, 1. Variable radii and fixed center at 0, minus 1. Option C, fixed radius 1 and variable center along the x-axis. Option D, fixed radius 1 and variable center along the y-axis. So we need to find out the type of circle that the given differential equation represent, the solution of the given differential equation represent. Okay. So first solve the given differential equation and then recognize the is the general solution which family of the circle represent. Okay. So as a hint to solve this, here we can separate the variable. So just separate the variable and then integrate to find the general solution. Okay. Try this question. If you know the integration, then you can easily calculate the general solution of this differential equation. You just need to separate the variable and integrate it. Okay. Okay, let's solve. So correct answer is option C, that is fixed radius 1 and variable center along the x-axis. So clearly we can write the given differential equation as dy y by root under 1 minus y square dy is equal to dx. We just separate the variable, write the term involving y with dy and term involving x with dx. There is no term involving with x with dx, so we only get dx. And then we integrate both sides. So the integration of y by root under 1 minus y square dy is equal to integration of dx. To integrate right hand side, use the substitution method. Substitute 1 minus y square as a new variable and then differentiate it and transform this integral with the new in the term of new variable. Then integrate that. You get minus root under 1 minus y square is equal to x plus c, and from here when you simplify this squaring both sides and then rearrange, we get x plus c whole square plus y square is equal to 1, and this is the equation of circle. The general form of the standard form of circle is the standard form of circle equation is x minus h whole square plus y minus k whole square is equal to r square, where h and k is the center of circle and r is radius. So here clearly r is 1 and center is x minus h whole square plus y minus k whole square. So h is minus c and k is 0. So center is minus c comma 0. So this family of circle is of with radius fixed radius 1 and variable center, that is minus c comma 0, and because this is minus c comma 0, y coordinate is 0. So this is along the x-axis. Clear? Next question. In this question, we are given a differential equation, that is dy by dx is equal to ax plus 3 by 2y plus f. Okay. So if the solution of this given differential equation represent a circle, then what is the value of a? Option 2, minus 2 and 3. Okay. So let's solve. Correct answer is option B, that is minus 2. So we have dy by dx is equal to ax plus 3 by 2y plus f. We can write this as ax plus 3 dx is equal to 2y plus f dy. We just separate the variable by by cross multiplication. We write this equation variable separable form. And now we just need to integrate this to find the general solution. So on integration, we obtain integration of ax plus 3 dx with respect to x. We get a integration of x is x square by 2 plus 3x, then is equal to y square plus fy plus c. So we can write this as minus a by 2x square plus y square minus 3x plus fy plus c is equal to 0. Okay. This is in the standard form, that is ax square plus bxy plus cy square plus dx plus ey plus f is equal to 0 on that form. So this represent a circle when the coefficient of x square is equal to coefficient of y square, and here coefficient of x square is minus a by 2 and coefficient of y square is 1. So we get minus a by 2 is equal to 1, and from here we get the value of a, that is minus 2. Okay. So if this given differential equation, if the solution of this given differential equation represent a circle, then the value of a is minus 2. Clear? Next question. We are given a differential equation y minus x dy by dx is equal to y square plus dy by dx, and we need to find the solution for this differential equation. Options are cy is equal to 1 minus x into 1 minus y. Option B, cx is equal to 1 plus x into 1 minus y. Option C, cy is equal to 1 plus x into 1 minus y. Option D, cx is equal to 1 minus x into 1 plus y. Okay. So let's solve. Correct answer is option C, that is cy is equal to 1 plus x into 1 minus y. So given differential equation is y minus x dy by dx is equal to y square plus dy by dx. So first bring dy by dx to one side. So we get y minus y square is equal to x dy by dx plus dy by dx, and then take common dy by dx. So we get x plus 1 dy by dx. So the equation become x plus 1 dy by dx is equal to y minus y square. And now we can separate the variable. We can write dy by y into 1 minus y is equal to dx by x plus 1. So now we just need to integrate this. So now we apply the partial fraction decomposition method to find the integration of right left hand side. So we can write 1 by y into y 1 minus y as 1 by y plus 1 by 1 minus y dy is equal to dx by x plus 1, and then integrate both sides. So integration of 1 by y plus 1 by 1 minus y dy is equal to integration of dx by x plus 1. So integration of 1 by y is log y, and integration of 1 by 1 minus y is minus log 1 by minus y, and integration of dx by x plus 1 is log x plus 1. And as arbitrary constant, we take log c. Okay, so we take log c so that we can manipulate our solution and simplify the solution, so that we can apply the property of logarithmic to simplify the solution. So we apply the property of logarithmic. Log m minus log n is log m by n, so we get log y by 1 minus y, and log m plus log n is log mn, so we get c into log c into x plus 1. Remove log both side, we get y by y 1 minus y is equal to c x plus 1, and from here we get x plus 1 into 1 minus y is equal to cy. So this is the general solution of the given differential equation. Okay. Okay, just wait for a moment. Okay, so next question is, we are given a differential equation log dy by dx is equal to ax plus by, and they are asked for solution of the differential equation, and options are a into e the power minus by plus b into a e the power ax plus c is equal to 0. Option b, a into e the power by plus b into e the power ax plus c is equal to 0. Option c, a into e the power by plus b into e the power minus ax plus c is equal to 0. And option D, none of the above. Okay, so as a hint to solve this, we will first take the exponential of both sides, so that the logarithmic is removed, and then we separate the variable and integrate. Okay, so just try. Any problem? Okay, let's solve. So correct answer is option A, that is A e power minus by plus b into e the power ax plus c is equal to 0. So we have given differential equation is ln dy by dx is equal to ax plus by. So we take the exponential of both sides, we get dy by dx is equal to e the power ax plus by, that is e the power ax into e the power by. So we can write this as we keep separate the variable. So you get e the power minus by dy is equal to e the power ax dx and integrate this. So when we integrating both side, so integration of e the power minus by is minus 1 by b e the power minus by, and integration of ex is 1 by a e the power ax plus c. So then multiply both side by ab, so you get b into e the power ax plus a into e the power minus by plus c dash is equal to 0, where the value of c dash is a b c. So correct answer is option A. Okay. Next question is, in this question we are given a differential equation, that is dy by dx is equal to e the power x minus y plus x square into e the power minus y. I need to find the solution of this differential equation. So which option is correct? Options are option A, e the power y is equal to e the power x plus x cube by 3 plus c. Option B, e the power y is equal to e the power x plus 2x plus c. Option C, e the power y is equal to e the power x plus x cube plus c. And option D, y is equal to e the power x plus c. Okay, so to solve this, we will simplify the equation and separate the variable and then integrate to find the solution of this differential equation. Okay, so try. Okay, let's solve. So correct answer is option A, that is e the power y is equal to e the power x plus x cube by 3 plus c. So given differential equation is dy by dx is equal to e the power x minus y x is square e the power minus y. Okay. So simplify this by taking out the common factor e the power minus y, we get dy by dx is equal to e the power minus y x square plus ex. Now separate the variable, so we get e the power y dy is equal to x square plus e the power x dx, and just integrate both side. So we get e the power y is equal to x cube by 3 plus e the power x plus c. Okay, simple. Next question. In this question, we are given a differential equation 2 plus sin x dy by dx plus y plus 1 cos x is equal to 0 and y at 0 is equal to 1. Then y at pi by 2 is equal to, options are 1 by 3, 4 by 3, option C minus 1 by 3 and option D minus 2 by 3. Okay. So at first solve the given differential equation and then find the general solution of the differential equation. And by using the initial condition y0 is equal to 1, find out the arbitrary constant of the general solution of differential equation and substitute that value of arbitrary constant and get a particular solution, and then take x is equal to pi by 2 to find the value of y at x is equal to pi by 2. Okay, so try. Which option is correct? Okay, let's solve. So correct answer is option A, that is 1 by 3. So we have given differential equation that is 2 plus sin x dy by dx plus y plus 1 cos x is equal to 0. So rearrange the rearrange this a bit, and so that variable can be separated, we get dy by y plus 1 is equal to minus cos x by 2 plus sin x dx. Now integrate both sides, so we get integration of dy by y plus 1 is equal to integration of minus cos x by 2 plus sin x dx. So integration of left hand side is clear, that is ln y plus 1, and to integrate right hand side, take a substitution for sin x, 2 plus sin x, take it as t. So when we apply the substitution method and integrate this, we get minus ln 2 plus sin x plus ln c. Okay, and then apply the logarithmic property. So when you apply the logarithmic property, we get ln y plus 1 plus ln 2 plus sin x, and that is log m plus log n is log mn. So we get log y plus 1 2 plus sin x is equal to ln c, and so we can remove log. So we get y plus 1 into 2 plus sin x is equal to c. This is your general solution. So now we use the initial condition, that is y0 is equal to 1, to find the value of arbitrary constant. So as y0 is equal to 1, so just take x, just substitute x is equal to 1 and y is equal to 1 in above general solution. We get 2 plus 2 into 0 is equal to c. So 2 into 2 plus 0 is equal to c. So the value of c is 4. So substitute back the value of c. We get y plus 1, 2 plus sin x is equal to 4. That is a particular solution. So now we have to calculate the value of y at pi by 2. So take x is equal to pi by 2. We get y plus 1, 2 plus sin pi by 2 is equal to 4. And the value of sin pi by 2 is 1. So we get y plus 1 into 2 plus 1 is equal to 4. And from here we get y is equal to 4 by 3 minus 1, and that is 1 by 3. So correct answer is option A. Okay. Next question. If a curve through the point 2 comma 7 by 2 and has slope 1 minus 1 by x square at any point xy on it, then the ordinate of the point on the curve whose abscissa is minus 2 is? Options are minus 3 by 2, option B 3 by 2, option C 5 by 2, and option D minus 5 by 2. So in this question, we are given a curve passing through a point 2 comma 7 by 2, and the slope at x comma y is 1 minus 1 by x square, and we know that slope is given by dy by dx. So here dy by dx is equal to 1 minus 1 by x square. So we have a differential equation, and the differential equation is, and as the curve passes through a point 2 comma 7 by 2, so you use this condition, and we have to find the ordinate of the point on the curve where the abscissa is minus 2. So we have to find y where x is minus 2. Okay, so try to solve. Hmm. Let's solve. Match your answer. So correct answer is A, that is minus 3 by 2. So given slope is 1 minus x square, that is dy by dx is equal to 1 minus 1 by x square. So this is your differential equation. So from here we can get dy is equal to 1 minus 1 by x square dx. We just separate the variable. Now we integrate this. So integration of dy is y, and integration of 1 is x, and integration of minus 1 by x square is 1 by x plus c. So now as given that curve is passing through a point 2 comma 7 by 2, so this equation general solution must satisfy this point. So substitute this point, so we get 7 by 2 is equal to 2 plus 1 by 2 plus c. So from here we get c is equal to 1. So y is equal to x plus 1 by x plus 1 is a particular solution. That is a curve passing through a point 2 comma 7 by 2. Okay. Now 8x is equal to minus 2. We have to find the ordinate of the point. So substitute x is equal to minus 2 in the above solution. We get y is equal to minus 2 minus 1 by 2 plus 1, that is minus 3 by 2. So correct answer is option A, that is minus 3 by 2. Okay. Next question is, we are given a differential equation x plus y whole square dy by dx is equal to 4, and y0 is 0. Initial condition is y0 is 0. We need to find its solution, and options are y is equal to 2 tan inverse x plus y by 2, option B; y is equal to 4 tan inverse x plus y by 4, option C; y is equal to 4 tan inverse x plus y by 2, option D; none of this. Okay, so we have to use a substitution for this differential equation to transform into the form where you can separate the variable. So what is the substitution? Just think. Okay, let's solve. Match your answer. Correct answer is option A, that is y is equal to 2 tan inverse x plus y by 2. So we have given differential equation is x plus y whole square dy by dx is equal to 4. Okay. So due to the presence of x plus y whole square, we cannot separate the variable. So we just take this as we just substitute x plus y with new variable v. So differentiate this, we get 1 plus dy by dx is equal to dv by dx. So now substitute dy by dx as dy by dx minus 1. So we get v square dy dx minus 1 is equal to 4. And when we simplify this, we get v square dy dx is equal to v square plus 4. So here we can separate the variable. We can write this as v square dv by v square plus 4 dx. And to integrate this, we add and subtract 4 on the numerator. And when we integrate this, we get integration of 1 minus 1 by v square plus 4 dv is equal to integration of dx. Integration of 1 is v and integration of dy v square plus 4 is 2 tan inverse v by 2 and integration of dx is x plus c. So substitute back the value of b, that is x plus y. So you get x plus y minus 2 tan inverse x plus y by 2 is equal to x plus c. Okay. Now we have to find the value of arbitrary constant by using the initial value. So it is given y0 is equal to 0. So we substitute x equal to 0 and y is equal to 0 in the above general solution. We get c is equal to 0. So particular solution is y is equal to 2 tan inverse x plus y by 2. Okay. Next question. Given differential equation is dy by dx plus 1 is equal to e the power x plus y. We need to find its solution. Okay. So which option is correct? Just figure out, try to solve. Okay, let's solve. So correct answer is option A, that is e the power minus x plus y plus x plus c is equal to 0. So given differential equation is dy by dx plus 1 is equal to e the power x plus y. So here we can substitute x plus y as new variable. So just take it as z. So we get, and when we differentiate this with respect to x, we get 1 plus dy by dx is equal to dz by dx. Now substitute the value of dy by dx from this. So we get dz by dx is equal to e the power z. Okay. So by using this substitution, we transform our given differential equation in such a form where we can separate the variable. So we get e the power minus z dz is equal to dx. We just separate the variable and now integrate this. So when integrating both sides, we get e the power minus z by minus 1 is equal to x plus c. Now substitute back the value of z, that is x plus y. So we get x plus e the power x plus y plus c is equal to 0. So correct answer is option A. Next question. So in this question, we are given a differential equation, that is dy by dx is equal to y by x plus f y by x by f dash y by x is. Options are, which is the solution for this differential equation? Mod f y by x is equal to c mod x, where c belongs to R. Option B, mod f y by x is equal to mod x plus c, c is greater than 0. Option C, f y by x is equal to c mod x, and c is greater than 0. And option D, none of this. Okay. So just recognize the form. This is the homogeneous differential equation. Okay. So how we solve the homogeneous differential equation? What is the substitution? So just recall and try to solve. Okay, so the correct option will be option C, that is mod fy by x is equal to c mod x, so c is greater than 0. So let's figure out. Given differential equation is dy by dx is equal to y by x plus fy by x by f dash y by x in the pure homogeneous form. So to solve a homogeneous differential equation, we substitute y by x is equal to v, that is y is equal to vx. And when we differentiate this with respect to x, we get dy by dx is equal to v plus x dy by dx. So we substitute dy by dx as v plus x dy by dx on a given differential equation. And when we rearrange, we get f dash b by fv dv is equal to dx by dx. We separate the variable after substituting the value of dy by dx as v plus x dy by dx. Now integrate. So when we integrate both sides, we get integration of f dash v by fv dv is log mod fv, and integration of dx by x is log mod x plus log c. So now we simplify this using the log property. So just apply the log property, we get mod fy by x is equal to c mod x, where c is greater than 0. Okay, so correct answer is option C. Okay, so in today class, we solved, we practiced some question based on differential equation. Okay, how we can solve a differential equation. At first we have to recognize how we can solve the differential equation. There's different method like variable separable method, homogeneous differential equation, and for each method there's different procedure to solve that differential equation. So we discussed many question. Okay, any doubt? All clear? Okay then, thank you.
Hello students, in today's lecture we are going to learn about electric fields, potential and capacitance. This is our theory part second. Okay, this is our disclaimer. In today's lecture we will cover first electric dipole, then we will discuss electric field due to a dipole, then we will learn torque on a dipole in a uniform electric field. After that, we will discuss work done in rotating dipole. Okay. Then potential energy of a dipole. Then we will discuss electric flux. After that, we will look at Gauss law. Then electric potential. Then electric potential energy. Then we will see relation between E and V. Then we will study equipotential surfaces. Then conductors and insulators. Then dielectrics and polarization. After that, we will see electrical capacitance. Then we will discuss sharing of charges. Then capacitor. Then capacitance of a parallel plate capacitor. Then we will discuss energy stored in a capacitor. Then energy loss during parallel combination. Okay, so these are the topics which we will cover in today's lecture. All right. So our first topic is electric dipole. Now here the question arises, what is an electric dipole? So look at here, this is the representation of an electric dipole. An electric dipole is formed by two equal and opposite charges which are separated by a small distance. Look at here at the figure. So here we have a two charges with opposite sign, positive charge and negative charge, and they are separated by a small distance. Okay, it means we call that an electric dipole which has two equal and opposite charges and there is some distance between them as shown in the diagram. Okay, here two charges, one minus q and one plus q. Both are opposite, but their magnitude is the same and distance between them is 2a. Okay, so we call this an electric dipole. Okay, so the important point here is this: the distance between charges is from minus q charge to plus q charge is 2a. Okay, and if we talk about the center, so this one, this is the center line, and the distance from center to minus q charge is a. Similarly, distance from center to plus q charge is again a. Okay, so this is the visual representation of electric dipole. Now let's talk about the dipole moment. Okay students, dipole moment is defined as the product of the magnitude of any one charge and the distance between them. We can say that dipole moment is the product of distance between two charges. It means minus q and plus q and the magnitude of the charge. So mathematically, dipole moment is written as P equal to Q into 2a p cap. Here p is the dipole moment, okay, q is the charge, and a is the distance from the center to the point charge. Center to the point charge as shown in the figure. Okay. So p cap is a unit vector which specifies the direction of the dipole moment, and the direction of the dipole moment is from negative charge to positive charge. Negative charge to positive charge. Okay. So this formula is very important for the exam. Now the next topic is electric field due to a dipole. We know the dipole. So first we will calculate the electric field at an axial point due to a dipole. Okay. So let's assume that we have a dipole which has plus q and uh, minus q charge, plus q and minus q charges, and the distance between these two charges is 2a. Okay. So assume that p, point p, is at a distance r from this point p uh, is at distance from r from the center of the dipole, okay, on the side of positive charge q. This one, this is the positive charge q, and the point p is this one. All right. Now due to individual charges, okay, that is due to this positive charge and due to this negative charge, we will we we will find the electric field. So let's see. So due to this minus charge, the electric field will be E minus q equal to 4 q upon 4 pi epsilon naught r plus a whole square p cap. Here listen carefully. Here r plus a means the distance from the minus q charge to point p, minus q charge to point p. Okay. So r plus a, the center to minus q charge distance is a, so r is this one plus a. Okay. So distance, total distance r plus a. All right, clear? Now p cap is a unit vector, okay, which is along the dipole axis. P cap tells us the direction of electric dipole, which is from minus q charge uh, to plus q charge. Okay. Now we will see what is the electric field will be due to the charge, due to positive charge, okay, plus q charge. So the formula is E plus q equal to q divided by 4 pi epsilon naught r minus a whole square p cap. Okay. P cap tells us the direction. Okay. So let's look at the diagram. We know that this positive charge q, here is at a distance a from the center. Yes or no? And the distance between point P and the center is R. Okay. Point P to center, okay, distance is R. All right. So if we subtract A from R, then we will get the distance from point P to charge Q, which is R minus A. That's why this formula becomes E plus Q equal to Q divided by 4 pi epsilon naught R minus A whole square P cap. Okay. Now we have seen that seen the electric field due to positive charge and also due to a negative charge. Okay. Now we will see the combined effect. All right, students. So what will be the total electric charge at point P? At point P. Think about it. So the total field at P E equal to 4 pi Q upon 4 pi epsilon naught into 4 AR divided by R square minus A square P cap. Okay. So this is the total electric field. If we talk about a short dipole, then a short dipole means that the distance R is much greater in comparison to A. That is, R is greater than A. If we increase the distance R, then in that case the electric field will arise due to the combined effect, which will be this one, E equal to 4QA divided by 4 pi epsilon naught RQ P cap. So this is due to a short dipole where R is greater than A. Okay everyone, clear? Yes or no? All right. Now we will calculate the electric field at an equatorial point due to a dipole. For this, we will see what the magnitudes of the electric field are due to positive charge and due to negative charges. So here there is a charge plus Q, okay, and another charge minus Q, plus Q and minus Q. All right. So here there is a charge, we know, plus Q and minus Q. Now at this equatorial point, so equatorial point is this one, P point. Okay, we need to find the electric field. All right, everyone. So due to the positive charge, the electric field, the magnitude of electric field will be E plus Q equal to Q upon 4 pi epsilon naught 1 upon R square minus A square. All right. And due to the negative charge minus Q, the magnitude of electric field will be E minus Q equal to 1 upon 4 pi epsilon naught 1 upon R square minus A square. In this way, we can calculate the magnitude of electric field for both charges. So the total electric field is in opposite direction to P cap. So the total electric field will be E equal to 2QA divided by 4 pi epsilon naught uh, R square plus A square whole power 3 by 2 P cap. Okay. Now look at here. If we talk about the direction uh, in this way. So if we find out the electric field at point P due to this positive charge, okay, the charge is positive. So direction is radially outward. And at due to this negative charge, the charge is negative. Okay. So the direction radially inward. When uh, R, small r is much larger than A, okay, then this formula simplifies to E equal to minus 2QA divided by 4 pi epsilon naught RQ P cap, where R is greater than A. All right. The next topic is torque on a dipole in uniform electric field. So how much torque will be applied on a dipole when it is placed in uniform electric field? Let's assume that we have a uniform electric field. Uniform electric field means, look at here, these parallel lines shows the uniform electric field. Okay, these parallel lines represent the uniform electric field. So this is the uniform electric field. So in this uniform electric field, we place a dipole. This is a dipole. Now we have studied what is a dipole. Is a dipole is where two equal and opposite charges are separated by some distance. So the distance between these two charges is 2a. Yes or no? So one charge is minus q and other charge is plus q. Okay. Now when we place this dipole in external electric field, then in that case, how much torque is applied? Let's see. So when a dipole is placed in an external electric field and it makes an angle theta, uh, with the direction of uniform electric field. Okay. So the direction of uniform electric field is along positive x-axis. Okay. Then a torque acts on this dipole whose magnitude is QE multiplied by 2a sine theta. Alright. So when you rearrange this, you get 2 QAE sine theta. So this is the torque when an electric dipole is placed in an external electric field. So the direction of torque is perpendicular to the plane in which vector P and vector E. It means the dipole moment and electric field lie. So in vector form, torque tau equal to P cross E. This is the vector representation of torque where P is the dipole moment and E is the electric field. So this is the vector representation. Okay. So we can say when an electric dipole is placed in a uniform electric field, the torque will apply on it. That is magnitude is 2 QA E sine theta. Okay everyone. Now we will calculate how much work is done in rotating a dipole. When an electric dipole is placed in a uniform electric field E, a torque acts on it which tries to align it. The magnitude of this torque is tau equal to Pe sine theta, where theta is the angle between the dipole moment P and the electric field. Now if we apply an external torque tau, external, which exactly balances this internal torque and rotates the dipole without any angular acceleration very slowly with infinitesimal angular speed from theta naught to theta 1, then the work done by this external torque will be W equal to integration theta naught to theta 1 tau external d theta, because tau external equal to Pe sine theta. Therefore expression for the work done becomes integration theta naught to theta 1 Pe sine theta d theta. Okay. Integrating, when we integrating the term, you will be get W equal to Pe cos theta naught minus cos theta 1. This results indicates how much energy the external torque provided to the system to move the dipole from one angle to another without any change in kinetic energy. So only a change in potential energy occurred. Okay. So what is the potential energy of a dipole? When an electric dipole is rotated from a direction perpendicular to a uniform electric field E to a particular angle theta, then in this process external torque has to do work, and this work done gets stored in the form of dipole's potential energy. Okay. So the potential energy of an electric dipole in the electric field is U equal to minus Pe cos theta, where P is the dipole moment and theta is the angle between the dipole and the electric field. U equal to minus P dot E. If written in the vector form, this expression becomes U equal to minus P dot E. The negative sign indicates that when the dipole aligns in the direction of field, theta equal to 0, in that case the energy is minimum, and when it is in opposite direction, that is theta equal to 180 degree, the energy is maximum. Therefore the dipole naturally tends to align in the direction of field so that the potential energy of the system is minimum. Now we will understand the concept of electric flux. Electric flux is denoted by phi E. Okay, flux, electric flux phi E is a physical quantity that indicates how much electric fields is passing through a surface. That is, how many electric field lines are passing through that surface. Okay, so if the surface is placed perpendicular to the direction of the electric field, the maximum flux passes. Okay, so suppose there is a surface and there is a small element ds. Look at the figure. Small element ds of that surface, and all electric field lines passing through this ds element in an electric field together represent the electric flux. Okay, and n cap shows the direction. So in mathematical expression, we can write phi e equal to integration e ds cos theta. Integration, when we write in vector form, it will be e dot ds, or we can say e dot n cap ds. Okay, so here it should be closed integration. Okay, closed integration e dot ds. Flux passes through the from a surface, closed integration e dot ds. Okay, the next topic is Gauss's law, and this is very important. All right, so let's see. According to this law, the total electric flux that passes through a closed surface is equal to 1 upon epsilon naught times the net charge enclosed within the surface. So if we consider that we have this surface, look at here. Okay, and let's assume that q charges are on this surface. All right, then our total charge enclosed within this surface is that charge divided by epsilon naught, which represents Gauss's law. Mathematically, closed integration E dot dA equal to Q upon epsilon naught. So phi E is equal to the closed integral of E dot ds, and that is equal to Q enclosed divided by epsilon naught. This is Gauss's law. Here Q enclosed means the algebraic sum of all charges inside the surface. Then the total flux will be what? Phi E equal to Q enclosed divided by epsilon naught. Suppose in this surface we have a two charges, positive charge and negative charge. So in that case, total flux will be 0. Why? Because total charges enclosed by the surface is 0. Plus q and minus q equal to 0. So we can say phi E should be 0. Okay. We use this law to calculate the electric field of symmetric charge distribution, like spherical, cylindrical, because we can say it directly relates flux to charge without complex integration. Okay, everyone, clear? Yes or no? Now we will understand the concept of electric potential. So electric potential means the amount of work done to bring a unit positive charge from infinity to that point without any acceleration. That is, the work done in bringing a unit positive charge from infinity to any point along any path is called electric potential. Mathematically, V equal to W upon Q naught. This is the formula for electric potential. Electric potential is a state function. Now, what is a state function? Think about it. We can say a state function means that it does not depend on the path. That is, it only depends on the initial and final positions. All right. Okay, so we know electric potential is a state function. Therefore, we say that the electric potential depends on initial and final position. Now, we will look at the electric potential which is due to a point charge. So, let's assume that a point charge is placed at the origin. Okay, this one at the origin. And if we calculate the electric potential at point P, okay, due to this point charge, uh, then in that case, potential will be V equal to 1 upon 4 pi epsilon naught into Q divided by R, where R is the distance from the point P to charge Q. Okay. Now the next topic is electric potential due to a system of charges. Means system of charges means that if we have a system and in that system there is a multiple charges as shown in the figure. Look at here. There is a multiple charges Q1, Q2, Q3, Q4 and Q5. Okay. So now we need to find out how to calculate uh, electric potential at point P. Okay, at point P due to all these charges. Think about it. You know the method? Yes or no? All right. So we know that potential is a scalar quantity. So if several charges Q1, Q2, Q3, Q4 and so on are present in space, in that case electric potential at any point, suppose at point P, will be the sum of the potentials due to each charges. Okay, and we will calculate here. So V equal to V1 plus V2 plus V3 and so on. This means the potential due to all charges will be added. And due to first charge, the potential is V1. Due to the second charge, potential is V2. And due to third charge, V3. Okay, similarly, potential due to all charges present will be added. So if we expand this a bit, then what is the potential due to a single charge? We know the formula, that is V equal to 1 upon 4 pi epsilon naught Q divided by R. Yes or no? So in this case, V equal to 1 upon 4 pi epsilon naught is common for all charges. So the equation becomes V equal to 1 upon 4 pi epsilon naught. Take is common for the first charge Q1 R1, for second Q2 R2 plus Q3 R3 and so on. Okay, so in this way we will get the total potential. If we represent this in a simple way, then we have V equal to 1 upon 4 pi epsilon naught summation I equal to 1 to n Qi divided by Ri. So this is the formula to calculate the electric potential due to a system of charges. Okay, and represent the number of charges. So if suppose there is a 5 charge, so I equal to 1 to 5. Okay. Third, we will look at the electric potential at a point due to an electric dipole. So at any point, we have V equal to 1 upon 4 pi epsilon naught P cos theta divided by R square. If we calculate the electric potential at a certain point on the axis of a dipole, then in that case theta will be 0 degree. So what will V become in the case of a dipole? V equal to 1 upon 4 pi epsilon naught P divided by R square. So this is the potential that we have on the axis of a dipole where theta is 0 degree. And if we consider the equatorial axis, theta equal to 90 degrees, in that case potential will be 0. Now we will look at the electric potential due to some common charge distributions. So first we consider the potential at a point which is at a distance r from infinitely long wire and whose linear charge density is lambda. Okay, so if we have a wire and this wire is infinitely long, then to due to this wire, if we need to if we need the electric potential at any point, in that case the potential obtained will be V equal to lambda upon 2 pi epsilon naught log r. Okay, and here if we consider a charge conducting a sphere of cell with the total charge q and radius capital R, then the electric potential at any point at a distance r from its center depends on whether point charge is inside the sphere on the surface or outside. So if r is greater than r, it means radial distance is greater than radius, meaning the point is outside the sphere. Then the potential is V equal to Q divided by 4 pi epsilon naught r. Okay, exactly as it is in the case of point charge. And if r equal to r, it means radial distance is equal to radius. So that is the on the surface. Then the potential is V equal to 1 upon 4 pi epsilon naught Q into uh, Q divided by r. And if r is less than r, that is inside the sphere, then the potential is constant and is equal to the potential at the surface. It means V equal to Q divided by 4 pi epsilon naught r. This is because the electric field inside the conducting cell is 0 and the potential remains uniform. Alright everyone. Now let's see. Uh, for a charged non-conducting sphere of radius r, the charge q is uniformly distributed over the entire volume. Okay, so we will examine cases similar to those discussed in the previous point. So now when r is greater than radius, it means radial distance is greater than radius. For that case potential will be V equal to q divided by 4 pi epsilon naught r. And second case, when r equal to radius, it means radial distance equal to radius of the non-conducting sphere. Then the potential will be V equal to Q divided by 4 pi epsilon naught into R. And for the third case, when R is less than radius, the potential for this case will be V equal to uh, Q upon 4 pi epsilon naught into 3R square minus R square divided by 3R cube, 2R cube. Okay, so this is the potential for all three cases. Alright everyone, clear? Any doubt here? Any doubt? All right. So if we talk about the center of the sphere, then at the center r equal to 0, then potential will be V equal to 3q divided by 8 pi epsilon naught into r, which is equal to 3 by 2 into Vs. Okay, Vs is q divided by 4 pi epsilon naught into r. So this is the potential at different points due to the sphere, outside, inside, on the sphere. Alright, so these all cases are very important for the exam. You need to remember all the formula. Now we will study the electric potential energy. When we assemble a system of charges, that is move different charges to their specific position, then in this process an external agency has to do work against the electrostatic force. This work itself gets stored within the system in the form of potential energy. So if we consider two point charges q1 q2, which are at a position r1 and r2, then the distance between them will be r12. Okay, so the formula for the potential energy stored between these two charges is u equal to 1 upon 4 pi epsilon naught q1 q2 divided by r12, where epsilon naught is the vacuum permittivity. The potential energy depends on the distance r1 r12 between the charges. Here r12 is the distance between q1 and q2. Okay, next is relation between E and V. So the relation between electric field E and electric potential V is exactly like that between force and work. So electric field is force per unit charge and electric potential is work per unit charge. When we move a unit positive charge from infinity to a point P without acceleration, okay, suppose a charge comes from infinity to a point P, okay, in that case uh, we have to do work against the electric field, and this work is stored as a potential in this okay, so in this process the total potential is Vp equal to integration infinity to point P E dot dr, where the negative sign indicates that we are working against the field. Now equipotential surface. An equipotential surface is a surface where the value of potential remains constant. That is a surface where the value of potential is same everywhere. In the case of a point charge, uh, concentric spheres which are around the center of the charge are equipotential surfaces. So at any point, the electric potential E is perpendicular to the equipotential surface. This means at the point from which E passes, the direction of electric field will be perpendicular to the equipotential surface, and E points in the direction where the potential is decreasing most rapidly. So we will study some properties regarding equipotential surfaces, and those properties are: first, an equipotential surface can be planar, solid, etc. But equipotential surface can never be point size. Okay. Second, an equipotential surface is single valued. Therefore, two equipotential surfaces never cross each other. Third property, the electric field is always perpendicular to equipotential surface. It means the angle is 90 degree. And fourth, when we move a point charge q between 2 point charges in an equipotential surface, that work done is 0. And next property, or we can say last property, when a conductor is in electrostatic equilibrium, okay, its surface is always also in an equilibrium surface. So these are the some important properties related to equipotential surfaces. All right, any doubt here? Okay. Now we will understand conductors and insulators. What is conductors? Conductors are materials uh, through which electricity can easily pass because they have free electrons which carry electric current, such as metals like copper, silver, and iron. These materials have very low resistance, which is why they are commonly used in electrical wiring and circuits. Okay. On the other hand, insulators are the materials that do not have free electrons or have very few, which is why electricity cannot pass through them, such as rubber, eonite, mica, plastic, etc. We use insulators for electrical safety, for example, in wire coverings, so that current does not leak and no one gets an electric shock. Okay. Next is dielectrics and polarization. Dielectrics are the insulating materials that transmit electric effects without actually conducting electricity. For example, mica, glass, and water are all examples of dielectrics. Ion free. When they are placed in an external field, their molecules' positive and negative charge slightly shift, making each molecule a small dipole. Okay, this shifting process is called polarization. And due to polarization, a net dipole moment develops within the dielectric material, which is in the opposite direction of the field. Okay, everyone. Next is electrical capacitance. Let's see. Electrical capacitance is a property of a conductor which indicates how much a charge is required to increase the potential of that conductor by 1 unit. If charge is given to a conductor and its potential becomes V, then the formula for capacitance is C equal to Q divided by V. This means the more charge a conductor can store without significantly increasing the potential, and the greater its capacitance is. Okay, and its SI unit of capacitance is farad, but in practical units, microfarad, nanofarad, or picofarad are used. Okay, all these concepts are very important for the exam, so you need to just remember all these formula and concepts. Now we will understand the concept of charge sharing in conductors. So let's assume that we have two charged conductors, one on which charges are q1 and q2, and their potentials are v1 and v2. Their capacitances are c1 and c2 respectively. Okay, if these two conductors are connected to each other, then in such a case the common potential obtained, and that will be V equal to Q1 plus Q2 divided by C1 plus C2, which is equal to C1 V1 plus C2 V2 divided by C1 plus C2. In this way, we can find the common potential when two charge conductors are connected. Okay, everyone? Clear? During the sharing of charges, some electrostatic energy is lost, which later appears in the form of heat or light. This loss of electrostatic energy uh, is shown by the formula. The formula is delta U equal to Ui minus Uf, which is equal to C1 C2 divided by 2 into C1 plus C2 multiply with V1 minus V2 whole square. Okay. When the charges are shared, the final potential of both bodies becomes equal, and the final charge they acquire is in the ratio of the capacitance, that is Q1 ratio Q2 ratio equal to C1 ratio C2. Okay. Next is capacitor. This is very important concept. Okay, everyone. Any doubt here? So, if we talk about capacitor, so we can say a capacitor is a device that stores electrostatic energy. It consists of conductors of any shape and size that carry equal and opposite charges, and an insulating medium between them that separates them. Okay, so here A and B are two plates. Now we will discuss two types of capacitor combinations. The first capacitor combination is here series combination, then parallel combination. Okay, so if we talk about the series combination, so we can say when we connect capacitors in series, it means the AND of one capacitor connects to the start of another capacitor. Okay, so this is, look at here in this figure. Okay, and of one capacitor, look at here, and of one capacitor connects to the start of another. Okay, then in the entire arrangement the charge remains the same across all capacitors, but the voltage divides. So in a series arrangement, V equal to V1 plus V2 plus V3. Okay, for C1 voltage V1, for C2 voltage V2, for C3 voltage V3. Okay, and here in the figure you see C1, C2 and C3 are all connected in series. So the potential C1 is V1, and across C2 is V2, and we can say across C3 is V3. So V equal to Q divided by C1 plus Q divided by C2 plus Q divided by C3. Upon rearranging it, it will be V upon Q equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. The equivalent capacitance Cs is given by 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus so on, which is equal to summation I equal to 1 to I equal to N 1 upon Ci. This is the formula to calculate equivalent capacitance in series combination. Okay. Next is parallel combination. So when we connect capacitors in parallel, one terminal of each capacitor is common to common and another terminal is also common. Okay, it means the same potential will exist across all capacitors. However, each capacitor stores different charge according to its capacitance. Therefore, the total charge is Q. So in parallel arrangement, Q equal to Q1 plus Q2 plus Q3. So CV equal to C1V plus C2V plus C3V. So the equivalent capacitance is given by Cp equal to C1 plus C2 plus C3. Direct add. This means that in a parallel combination, capacitance add up and the effective capacitance is greater than individual capacitance. Okay. All right. Now we will calculate the capacitance of a parallel plate capacitor when there is a vacuum between the plates of a parallel plate capacitor. Then we will look at the capacitance of that system. So each plate has charge Q and the area of plate is A. Okay. Then the surface charge density is sigma equal to uh, Q divided by A. And then the magnitude of electric field between the plates is mod of E equal to sigma upon epsilon naught, which is equal to Q divided by epsilon naught into A, where we find out the potential difference between the plates V equal to mod of E into D. We know the value of E, that is sigma upon epsilon naught. So just substitute here and solve it. You will be get sigma D divided by epsilon naught, which is equal to QD divided by epsilon naught into A. D is the separation between the two plates. So the formula for capacitance is C equal to Q divided by V, which is equal to epsilon naught into A divided by D, which clearly states that capacitance is directly proportional to area A and inversely proportional to separation D. All right, everyone. Now we will see what effect is produced on its capacitance when a dielectric material is filled between the plates of a capacitor. When a dielectric material is completely filled with the plates of a capacitor, the capacitance of the capacitor increases. Okay, so the function of a dielectric is to weaken the electric field and to increase the energy storage capacity. If the dielectric constant of the dielectric is K as shown in the figure, then new capacitance is C prime equal to K epsilon naught into A divided by D. Okay, which is equal to K into C naught, where C naught is the capacitance in the case of vacuum. This means that the higher the dielectric constant, the higher the capacitance. When the thickness of the dielectric slab is T and it is partially inserted between the plates, that is T is less than D, then in that case the effective capacitance is C prime equal to epsilon naught A divided by D minus T plus T by K. This formula indicates that both the thickness of the dielectric slab and the dielectric constant together influence the capacitance. Okay. Next is when a parallel plate capacitor is charged, an attractive force acts due to opposite charges between these two plates. Okay, so the magnitude of this force uh, F equal to sigma square A divided by 2 epsilon naught, which is equal to Q square upon 2 A epsilon naught, which is equal to CV square upon 2D. This indicates that the force depends on the surface charge density sigma, total charge Q, capacitance C, and voltage V. Okay, and the distance T between the plates. As the voltage or charge increases, the force also increases. Additionally, the energy stored between the plates of a capacitor is distributed within a volume. That's why we call it energy density. And the formula for energy density is U equal to U upon volume, which is equal to 1 upon 2 epsilon naught E square. This indicates that the stronger the electric field E, the more energy per unit volume will be stored. Okay, any doubt here? All right. Now let's see energy stored in a capacitor. When a capacitor with capacitance C is charged to a potential V, electrostatic energy is stored in it. This energy is actually the work done by an external source to accumulate charge on the plates. This stored energy can be written in different forms depending on the available quantities. So U equal to 1 by 2 CV square, U equal to 1 by 2 QV, and in terms of C it will be U equal to 1 by 2 into Q square by C. All three formulas represent the same energy, only the variables are different. Okay, so this energy is stored in the form of an electric field. So we know this energy is stored in the form of an electric field between the plates of the capacitor, and when the capacitor discharges, this energy performs work in a circuit. Okay, such as lighting a bulb, running a motor, etc. So therefore, the capacitor is also considered an energy stored device. Now we will look at energy loss in parallel combination. So when two capacitors, one charged to potential V1 with capacitance C1 and other with capacitance C2 at potential V2 are connected in parallel, charge distribution occur between them so that their final potential becomes the same. During this redistribution, some electrostatic energy of the system is lost, which is dissipated in the form of heat or light. The formula for this energy loss is 1 upon 2 C1 C2 divided by C1 plus C2 into V1 minus V2 whole square. Alright, thank you for your attention. Now we will solve some practice questions based on these topics. So are you ready for the practice question? Yes or no? Okay. Write in the chat box. Hello students. Now we will solve some practice questions based on electric charges and fields and capacitance. This is our disclaimer, and here we will solve some practice questions. So the first question: a large insulated sphere of radius r charged with q units of electricity is placed in contact with a small insulated uncharged sphere of radius r prime and is then separated. The charge on the smaller sphere will be now what? It is asked what will be the charge on the small sphere. So given options: option A, q into r plus r prime; option B, q into r minus r prime; option C, q divided by r prime plus r; and option D, q r prime divided by r prime plus r. So which option is correct? Please solve this question everyone and tell me which one is correct. Yes, please solve. You have some time. Which one is correct? So the correct option is D. Okay, let's see the solution. When we connect two conducting spheres whose radii are different, r and r prime, as shown in the figure, okay, with a wire, charges continue to flow until the electric potential of both becomes equal. Assume the total charge of the system is q. So at the beginning of the solution, we assume that at equilibrium, the smaller sphere has charge q, and by the principle of conservation of the remaining charge on the larger sphere will be q minus q, capital Q minus small q. Now using the formula for potential V equal to kq divided by r, we write this equation for the both potentials, that is VR prime equal to kq divided by r prime and VR equal to k into q minus q divided by r. So when we equating both, you will be get qr upon r prime equal to q into q minus q divided by r. When we solving this, you will be get this term. It means we can say q upon r equal to q into r plus r prime divided by r prime. So q equal to q r prime divided by r plus r prime. Okay, so correct option is D. Next question. Consider a finite insulated uncharged conductor placed near a finite positively charged conductor. The uncharged body must have a equal potential. So here the question asks, what will be the electric potential of an finite insulated uncharged conductor if it is placed near a finite positively charged conductor? So given options: option A, less than the charged conductor and more than at infinity; option B, more than the charged conductor and less than at infinity; option C, more than the charged conductor and more than at infinity; and option D, less than the charged conductor and less than at infinity. So which one is correct? Please solve this question, everyone, and tell me which option is correct. You have some time. Tell me which one is correct. So the correct option is A, less than the charged conductor and more than at infinity. Okay, so let's see the solution. When an insulated uncharged conductor is placed near a positively charged conductor, the phenomena of electrostatic induction occurs. All right. So as a result of this, charges are induced on the uncharged body. The side closer to the positive body acquires negative charge, and further side acquires a positive charge. Okay. So due to this induction, the uncharged conductor acquires some induced charge. So electric field lines always go from positive charge to negative charge, and potential always increases. Potential always decreases here. Okay. In the direction of field. This means that the potential of positive charge conductor is highest, and when we move from it towards an uncharged conductor, the potential decreases. Okay. So the potential of uncharged conductor will less than the potential of charged conductor. Alright everyone. Next question. The electrostatic potential inside a charged spherical ball is given by phi equal to ar square plus b, where r is the distance from the center, where a, b are constants. Then the charge density inside the ball is what? So here question asks, what is the charge density inside this ball will be? Given options: option A minus 6 a epsilon naught r, option B minus 24 uh, pi a epsilon naught, option C minus 6 a epsilon naught, option D minus 24 pi a epsilon naught r. So which option is correct? Please solve this question everyone. You have some time. Which one is correct? Okay. Anyone? So the correct option is C, minus 6 a epsilon naught. Let's see the solution. First, we will use the relation between potential and electric field E. Okay. So we know E equal to minus d phi upon dr. When we differentiate the given potential, we get electric field, that is equal to minus 2ar. So by the Gauss theorem, for a spherical Gaussian surface of radius r1, uh, closed integration E dot ds equal to q and closed divided by epsilon. Alright, so here this theorem states that the total electric flux through a closed surface is 1 upon epsilon naught times the total charge q enclosed within it. So for a sphere, the flux E into surface area, which is E into 4 pi r square. So the solution equation will be E 4 pi r square equal to q upon epsilon naught. Here r square. Okay. So upon substituting the value of electric field, we get enclosed charge minus 2a r into 4 pi r square equal to q enclosed divided by epsilon. So solving this, you will be get the value of q of r, that is minus 8 pi epsilon naught ar cube. So we have q of r equal to minus 8 pi epsilon naught ar cube. This result indicates that the charge density is constant and uniform inside the ball. So the correct answer is C. Okay. So to find the charge density, we will consider a spherical cell of at a distance, radial distance r. So rho equal to dq upon dv. So just substitute the value of here dv. You will be get dq equal to minus 24 pi epsilon naught ar cube dr. So just you will be get rho after substituting the values. It means rho equal to minus 6 epsilon naught a. Okay. Next question. 2 points P and Q are maintained at the potentials of 10 volt and minus 4 volt. Then the work done in moving 100 electrons from P to Q is what? In this question asks how much work will be done to move 100 electrons from point P to point Q. Okay, P to Q. Given options A, B, C, or D. So which option is correct? A, B, C, or D? You have to find out correct one. Please solve this question, everyone. Which one is correct? Let's see the correct answer. So D option is correct. So in this question, we are given the potentials of two points P and Q. So Vp equal to 10 volt and Vq equal to minus 4 volt as shown in the figure. So the solution is based on a simple formula, that is work done. So W equal to N into minus E into Vq minus Vp. So the equation becomes this one. So just substitute the values to determine the value of W. You will be get W equal to uh, plus 4 2.24 into 10 to the power minus 16 joule. Okay, a positive work done means that the to move the electrons from point P to Q, an external agent had to provide energy, that is work had to be done. Okay, so D option is correct. Next question. In the question, a graph is given which shows the variation of electric potential V with distance x from a fixed point. While looking at this graph, it is asked what will be the value of the electric field when the distance x is equal to 2 meter. The options are option A 0, option B 6 by 2, and option C 6 by 1, and option D 6 by 3. So which option is correct? Please try to solve this question, everyone. So the correct option is A. Okay, let's see the solution. So in this question, a graph is given which shows the relation between electric potential V and distance x. So as we know, the formula between electric potential and potential is equal to minus dV upon dx. This means that the electric field is the negative of the slope of the potential distance graph. So and around x is equal to 2 meter, here the line is perfectly straight. This means here the potential is constant. Yes or no? So V equal to constant. If V constant, so dV equal to 0. If dV 0, it means E equal to 0. Okay. So next question. The electric potential V at any point x, y, z in space is given by V is equal to 4x square volt. The electric field at 102 meter in volt per meter is what? You have to find out the electric field. So please solve this question, everyone. So the correct option is B, 8 along the negative x-axis. The relation between electric field and potential is that the electric field is negative gradient of potential. So in Cartesian coordinates, uh, equal to minus del V upon del x I cap minus del V upon del y j cap plus del V upon del z k cap. So just substitute the values and differentiate. You will be get E equal to minus 8x I cap. So at 0, 1, 0 and 2 equal to minus 8 I cap. So magnitude of the electric field is 8 volt per meter and the direction is along negative x-axis. This is very simple questions. This is the last question. Okay. So assume that an electric field equal to 30x square I cap exists in space. Then the potential difference VA minus VO, where VO is the potential at the origin and VA is the potential at x is equal to 2 meter per second. So which option is correct? Given option A 120 joule per coulomb, option B minus 120 joule per coulomb, option C minus 80 joule per coulomb, and option D 80 joule per coulomb. The question states that is given, exist in space, and you have to find out the potential difference. So correct option is minus 80 joule per coulomb. Okay. So electric field and potential difference, the relation is we know dv equal to minus edx. So just put the limits v naught to va and just substitute the value of e. You will be get integration vo to va dv equal to minus integration 0 to 230 x square dx. So when we performing the integration, you will be get va minus vo equal to minus 10 into 2 cube minus 0 cube. It means the potential difference is minus 80 joule per coulomb. Okay, so C option is correct. All right, any doubt? Thank you for your attention. That's all for the today. In next lecture we will start a new chapter. Okay, thank you for your attention. Thank you.